Is Kotlin hard to learn? Not if you have the right roadmap. In this video, I have compiled the essential basics from the first section of my Kotlin and Java Compose bootcamp. We are going to cover variables, null safety, loops, and control flows. By the end of this video, you'll have the foundation you need to start writing Kotlin code. And if you want to take the next step and use this code to build Android applications with Google's modern toolkit Java Compose, check out the full course in the description. Let's get started. Okay, so before we write any piece of code, actually we have to install the IDE or the environment which we're going to actually write the code. And luckily enough, we have Intelj IDE, which is actually the leading IDE for professional development in Java and Kotlin. So actually this is made by JetBrains, which is the creator of actually Kotlin. So what you can easily do, this is going to be the Intelj IDE for Ultimate Edition. So if you want to purchase this, but I will not recommend this for now. So if you have it, you can just continue with it. If not, then you can just download Ultimate Editions here. So basically, depending on your operating system, then you can download the file and actually follow the instruction of installation, which is actually pretty straightforward. So you can download this Intelj IDE, and throughout this course, we're going to use this and Android Studio. Okay, so for this case, let's start to create our project. Let's click here, new project. And here, basically, we're going to be greeted with different things. So you can create this, for example, with Kotlin, Groovy, or Java. So we're going to select Kotlin here. And for the name, we're going to call this Hello World. And you can save it to different locations. So for our case, we're going to leave this as the default. And if you want to create a Git repository, you can actually create it from here. So the build system, leave it as how it is. So you can use Maven, Gradle, or Intelj. So let's select this one, Intelj. And the JDK, this one is going to be bundled with actually Intelj IDE. So for this case, let's just click create here. No need to access these advanced settings. Just click here, create. Okay, so we're going to be greeted with this code here. So if you don't know anything about this, don't worry, we're going to explain this step by step. So basically, I'm going just to delete everything so that we can write this from scratch. So let's press Command A or Control A to actually select everything and delete it. Okay, so let's write here. We have a blank editor, so we can start to write our code. So the first case, we're going to use a fun keyword to actually denote that we want to create a function. And any Kotlin program actually requires a main function. So when we use this main keyword, you can see there is an icon that is going to be actually letting us to run this piece of code. Then we're going to use these curly braces and actually to denote that this is going to be the body or the place where we're going to write our piece of code and execute it inside here. So don't worry about this. We're going to speak more this later. So for now, we want to print to the console. When we write this Println, this one is going to translate to what we are writing here. So for example, we're going to add here, hello. So this is going to be the first program you actually write in any type of programming language. And for Kotlin, this one is going to be print hello world. Directly, let's click here, run. Now you can see the program prints hello world. So congratulations on writing your Hello World program. Okay, so in any programming language, there are different ways of printing to the console. And actually, in Kotlin, we have several ways. So for example, we have the Println. So the Println, this one, as how it says, it's going to print to the next line. So we can use a Println to print to the next line, or we can use another thing. So let's start with print first. So print, this one is going to print on the same line. So let me demonstrate this. So we can say, hi, my name is, and let's leave here a little bit of a space. Now let's use here Println, and let's write here Said. Okay, now let's try to run this. You can see everything is actually printed on the same line here. Hi, my name is Said. So because we used this print and actually Println, so this one is going to keep them in the same space. Let's use another Println. And now let's write here, learning Kotlin. Now let's try to rerun. And then you can see this one is actually going to the next line. Now, this is just similar to using the print, but with one thing. So let's just use here the Println. Let's remove also this. Now let's try to run this. Okay, so you can see everything is actually in the same line. So instead of this, we can just use an escaping sequence. So this denotes that we have to start in the new line. So you can see Println. So now let's run this. So you can see the same effect actually applies here. Here, hi, my name is Said, and in Kotlin, because we used here, this one is going to denote that we have to add one extra line. So when we use Println, that is going to have the same effect as how using this escaping sequence here. Okay, so we have seen how we can use different println and print functions. So another important aspect to understand in Kotlin is actually comments. So comments is going to help us to leave informations. So for future developers or for ourselves to remember what we have written here. So for example, we can say by printing a comment is using these two slashes here. So with this, the compiler is going to ignore anything which we write here. So you can see whenever we write anything here, then the compiler is going to actually ignore this. So we can say here, for example, print a student name. So in future references, after 5 years, then when we look to this code, we'll understand, okay, so we left here a comment for our future self or for any developer who is going to actually lead this. And there are different ways of declaring comments. So for example, here we declared the student names. So another case is using actually this one is called a multiline. So if you have a lot of things to actually show, so we can keep this way. And now here we can start to add the comments. So we can add huge lines, for example, here. So if we have a huge comments, then we can add here these comments. So this one are going to be pretty handy when we are writing our programs in order to make our code more readable and understandable. Okay, so in any programming language, you have to store data. So how can you store data in Kotlin? Actually, we have a concept that is called variables. So variables in programming is like a box with a label on it. So we have a box, and inside the box here, we can store information inside that box, like, for example, numbers, words, and etc. You can use that information later in your programs, and some boxes can change the information and some boxes cannot change. So in Kotlin, to actually declare a variable, you have to actually use a certain syntax. So the first way is using the val keyword. So this is a reserved keyword which you cannot use as a name. So for this case, we are telling the Kotlin compiler, hey, we want to declare a variable which is going to hold a piece of information that we can try to use them inside our program. So for example, we can declare a variable that is called the name. So now this is the identifier of this particular variable. So you can look at a file, for example, if you have a file that is going to store, for example, purchase orders or anything else. So for this case, we can actually assign this. And when we provide this equal sign, this one is going to be an assignment operator. That means we want to assign this variable a certain type or a certain value. Then, for example, we want to assign this a name. So, for example, we can call Said. So for this case, we have a variable declaration. So this is the syntax of Kotlin to declare a variable. Now we can try to print this. So let's call here println. Then we can say hello. Then we can do something that is called the string concatenation. So we can concatenate between one string to another. So we have that variable and we can use a plus sign and call the name. So this directly here is going to print hello name. Now let's try to run this. Now you can see we have hello side. So let's keep here a little bit of space. Let's rerun again. You have a net. So you can see we have printed here. So this is how you declare a variable in Kotlin. So in Kotlin, we have a concept of mutable and immutable values. So we have immutable variables. So immutable variables are variables which cannot change in values. So let's say, for example, we have a box, and whenever we keep items on that box, then we can never change that box to another items. So for this case, as how we have seen here, we have the value. This one is actually named and is actually assigned to Said. So to make redeclaration, we can use the name. Now, whenever we try to reassign this to another name, for example, John, then you can actually see here Kotlin is actually showing us we cannot reassign these values because it's already been assigned. So for this case, we have to change. So for example, let's declare another variable. So, and here we can use another keyword in Kotlin that is called the var. And this means is actually a variable that can actually change. So for this case, let's declare, for example, an int. This one is going to be of age. Then let's give it, for example, this one is going to be 25. So for now, let's try to println the age value. And you can actually see this. Let's try to rerun. Okay, so now we can see here our age is actually 25. Okay, now let's reassign this value of variable to another item. So for example, let's say this guy has increased to 31. Now let's try to do println and print again the age. Now when we try to rerun again, you can see that the age is actually 31 now. So this is the concept of mutable and immutable variables. So now we have this one here is going to be immutable variable. Let's skip the comment here. And here we have variables. Okay, so we have seen how we can declare variables in Kotlin. So right now we want to look at data types. So before we proceed here, I'm going to create a new file. So basically we can right click here and create a new Kotlin class of file. Let's call this data type. Let's click enter in order to create a new file. So I'm going to organize the code in different files so that we can easily access them. Okay, so now let's create another main function. So we can just write main and press tab so that we can see. So you can see here, whenever you type main, this one is going to be a shortcut. Now press tab here in order to generate the main function here for our data types. Okay, so we have different types in Kotlin, and this represent different types of items which we want to store. For example, whenever we want to store numerical variables, we can use an int. So int is actually a data type in Kotlin. So we can declare here by using val. Let's go, for example, we have apples. And these apples here, we can actually declare the values. And by using these two columns here, we can actually specify a certain data type. So for int, this means for integers. We can say, for example, we have 5 apples. We can define another, for example, bananas. And here we can declare an int. This is going to be a data type. We have 3. And we can do a simple calculation between these two values. So let's create here a variable and call this fruits. And it's a great practice to actually give meaningful names. So if you don't know, in Kotlin, we are using here camel cases, which is a naming convention in Kotlin. So for example, we can take apples and use a plus sign. Actually, this is an additional operator which we can use to actually add two values. So here, for example, we're using the assignment operator, and after that, then we can use two variables to actually assign them by pressing. So now we can perform a println function. Total fruits are, and we can use a plus sign here to concatenate between two strings. So now we have a string and a number. So let's call total fruits. Now let's try to run this. So now when we run here, our console output is going to show us that we have total fruits are 8. So when you take 5 plus 3, actually is 8. And then this is what we print. So this is the first data type. Let's add here a comment. So we have an int data type. So we have different data types. So int is going to actually have a limit. And actually, when we want to actually store very big numbers, we're going to use a long. So let's declare here a variable and call, for example, distance to the moon. Now, actually, when you use these two colon, then we can call this is going to be a long. Okay, so you can see here we have this variable that is called distance to the moon. So you can notice here we have a really long number, and you can see we are using here an L at the end. This one is going to denote that we want this to be long. Actually, I'm using this underscore here in order to differentiate to have like commas, because we cannot use here a comma like this. So when you use underscore, or you can just remove the underscore, but You can use the L in order to denote for a large number that is going to be a long. Now, for example, we can try here to write another println. Then we can concatenate this with the distance to the moon and actually print this. Let's try to rerun again. So you can see here we have the distance to the moon that is actually printed here. So this is long, and these are the common data types which you're going to actually face in your day-to-day programming. Okay, so we have another type of data type that is going to be storing decimals. So here we had for long, so we can add another comment. Let's call just this long data type. Next, we want to store decimals. So we have two types of decimals. So the first one is going to be double. So for example, whenever we want to store decimals like petrol price, let's go like this. We can declare this by using double. Now let's go with 4.75, for example. Then we can declare here, for example, we have liters. So we're going to use 10.0 liters, for example. Now, whenever we want to compute, for example, the total cost, we can just call here total cost. That is going to be as simple as multiplying two variables. So let's call total price, petrol price multiplied by liters. Then let's try to println here. So we can say total fuel cost. Let's add here our total cost. For this, you can see we are representing decimal points inside here, and we don't have any problems. Now let's try to run here. You can see our total fuel cost is going to be 47.5. Okay, so we have another data types in decimals, which you are going to encounter this. So this one is going to actually store decimals, but with less precision than doubles. So double can actually store more points than this another data types. So this one is going to be the decimals, but this one is going to be called a float data type. So for example, if we want to actually store the PI, we can use 3.1f. Then we have to use f at the end in order to declare float. So you can see here we have an error because this is actually a double. And in order to actually make this to be a float, then we have to add f at the end. You're going to see this more often whenever you progress with Kotlin. So now we can write here println function. So we can say the value, for example, and then we can use here a PI variable to actually print this. So this is how we store variables. Then there is another data type which we have already seen in different places. So for example, let's go with this one is going to be strings. So we have seen this, like let's go. This one is going to actually store the value in terms of text. So here we can say first name like Said. You can store last name. So you can actually create another value that is called, for example, full name. So you can use first name. Then let's concatenate. So we want to add here a space. And then let's call here last name. And actually, let's print the full name. Now you can try to run here and actually see. Okay, so you can see here the value that is Said Hamoud. Okay, so another important data type which you're going to encounter here is actually called Boolean. So Boolean, these are going to be values that represent true or false. So actually we have true state, true or false values. So for example, we can have a variable that is going to say if the user is logged in. So this one is going to be Boolean. Now we can assign this to, for example, true or false. Sorry. So if the user is actually logged in, then we can use these to perform, for example, conditional execution, which we're going to do later. Now, another important data type that you're going to encounter is actually called a character. So a character is going to represent a single character as how it is. So here, for example, in strings, we have a sequence of characters. But whenever we want, for example, to have a single character that we can use them, this one is going to be used. For example, let's call here grade. And we can declare this by using a char. And here we're going to use single quotation mark. And for example, A. So in the previous lesson, we saw how we can actually declare different data types. Now we can try to convert data types from one type to another type. So for example, here we have apples, and this is declared in int. Now what if we want this to be a long or a double or anything? We can actually convert this back to another data type. So let's come here, for example, and declare another variable. So let's call this apples long. So for this case, we can actually call the apples, and then we can try to convert this by calling to long. So by calling to long, this actually directly converts to long. So here we can declare even the data type to be long. And everything here is looking perfectly. Let's try to Println and call apples long. So in Kotlin, every data type is actually an object, which we're going to discuss later. So let's press Command and click, or you can press Command B or Control B in PC. And you can see here, this is actually an object, and it contains a lot of values. And here you can see we have the minimum and the maximum value. So this actually encodes the values that can be actually selected. So when you come also here to an int, and when you press Command B, you can see here is where it's going to be declared. Also, it contains a minimum value and the maximum value that can be held within this. So for example, let's take this. Let's go to our data types here. So this one is an int minimum value. So let's call this int. So this is the maximum value which an int can actually hold. So if we add this value to, for example, let's skip here 2, you can see we're getting an error. So this one is actually expecting to be an int, but it's actually a long, which is a very big number. So now let's call here long, and actually we don't have any problem. Now, when we create here, for example, we want to change this. So this one is let's call just long, not int minimum value. Let's call here long value because this is a very big number. Now we want to convert this to int. What we can do here is use the long value and call to int. Now you can see this number here. Now let's try to Println here. Now let's try to run here our value so that you can see the effect that is going to be caused. Okay, so you can see here we converted this to an int, and actually it is having a value that is not what we expect, because this is going to be out of range of an int. So basically it's going to truncate. So sometimes you can receive different outputs whenever you convert a large data type to a smaller one. So you must be careful when you're converting these data types. But if, for example, we keep it in a range, let's just keep here 1000 or 10,000. This is within the range of an int value. So let's try to run here. And you can see we are getting the same value because we converted this from a long to an int. So all of these values here, we can convert from one data type to another data type. So for example, let's call also first name and call this 2. You can see we can convert to int, to long, to other things. So we can convert here by using 2. You can see we can actually convert this from one data type to another data type. So we have seen all of these data types, but we want to speak about the $1 billion mistake, which is called null values. So if you have experience with other programmings, you know there is one data type that is called the null. And actually the creator of null called it the $1 billion mistake. So let's see here an example. So let's create here a new file. Let's go to our source, press Ctrl, new, and select file. So imagine you are ordering a package online and you get the delivery notification that you have to go to your front door. Then you find an empty box. Now imagine you have to open that box and take out the item inside to proceed with your day. What do? You can't do. You are just stuck. And actually, if a program actually encounters this, it's going to fail and actually throw an error. So we have to deal with nullability, and Kotlin is actually a safe programming language. Let's create here our main function. So we say that in Kotlin, there is a safety rule. So Kotlin solution is actually simple but brilliant. So for example, let's declare here a variable. And let's call this first name. Okay, so this one is going to be of type string. Okay, so now I want to reinitialize this variable to null. So let's go here and call this one to null value. You can see here we're getting an error. Actually, we use the variable, which is actually, we can reinitialize this to another value, but we are getting an error. So you can see null cannot be a value of null type string, because this by default is actually not nullable. So we have to explicitly state that we want this to change to be a nullable one so that we can do this. So for this case, we cannot change this value. Okay, now let's just keep it here. We can declare another value. So let's call this middle name, for example. But this middle name, we can actually be null or non-null. So for case, here we can call, for example, by adding this question mark here, we tell Kotlin compiler, hey, this value can be null or non-null. So for now, let's try to print Println here, and let's print the middle name. Because here we have already initialized this to an actual string value. Actually, this one is going to print the actual value. Now let's try to run this first. So you can see it has printed this. Now let's try to actually reassign this middle name. Let's send this to. Now you can see we have the null value. So we have first this cell, then again it's going to be null. So because we have reassigned this to a null values, now we cannot perform operations to a null. So for example, what if we want to convert this name here to actually contain uppercase? So in Kotlin, we have functions because we say that string is actually an object. Then we have functions that we can use to actually convert this to uppercase. So inside here, middle name, we can actually use the dot operator and actually call a function. So now we want to actually convert this to uppercase. So we can just call here uppercase. You can see directly here we are having an error. Only safe or non-null asserted values are allowed here, because the compiler cannot guarantee if this value is actually null or non-null. And basically you can see here we have actually declared this to null. Even if we remove this, still we are getting the error because the compiler cannot guarantee this, and we have to explicitly handle this. So how can we handle the null values in Kotlin? So there are several ways of actually doing this. So I'm going just to pick you one thing. So we have an if-else statement, which is just a conditional statement that is going to check the condition. If the window name is actually not null, then actually we have to perform operations, and else we can tell the user. So we're going to see more about conditional execution in later videos. So we can use an if. So this is the keyword. Inside here, we can define the condition. So our condition is actually the middle name, and we can use the assignment operator. So when we use this exclamation mark, we are negating the value if it's not equal to what? Actually, the null value. So for now, we are negating this value. If it's not actually equal to null, then we can perform here an operation. So we can call, for example, uppercase middle name. Now we can call our middle name dot uppercase. Now we can do the println And here we can use an else, but we can say no middle name. So for now, let's just remove this. And now you can see we are checking here. So this one is actually a normal way of checking, and it's a classic way of checking throughout other uh, programming language. So if you have a background in Java, actually this is the way of dealing with null values. So you're checking first the condition that, hey, if this is not actually equal to null, then we can perform the operations. And if actually there is no, so if this actually evaluates to false, then this is going to be executed and actually print this. So now let's try to run this again. And here you can see we have this in uppercase. Okay, so this was the first way. So I'm going to add here Println to check the if check. Okay, so there are numerous ways of actually handling the null values. So in Kotlin, we have another case, which is called the safe call operator. So how is this actually working? So with the safe call operator, so for example, we can call here uppercase middle name. Now we can actually call the middle name, but actually this for now is actually going to be a null value, because you can see we have a string that is actually nullable. So in order to do operations here, we can use a question mark, then we can use the dot operator. So here we are telling the compiler, hey, if this is actually null, then ignore this, don't execute this, so that we cannot crash our application. And if not, then just return and perform the operation. So for this case, we can just call here the uppercase. So we're using first the question mark, which is actually telling the compiler, hey, if this is null, then ignore these operations. If not, then proceed with the operation. And now we can just println here and call uppercase middle name. Okay, so another way of handling null values in Kotlin is actually using the Elvis operator. So it's going to be similar to this. Let's just copy this. Let's paste it here. And also, let's change this or empty. So uppercase middle name or empty. What we want to do, if the value is going to be null, then we have just to perform these operations. And if not, then we can just return another value to let the developer know, hey, this is actually no middle name. So for this case, let's just change back here our middle name back to null. So you can see the operation is actually not going to be successful. Then we are going to use the Elvis operator. So we add another question mark and these two notes. Now we can tell, hey, if this is null, then you can return something else. So for example, we can write or just write no name. And now we can let the user know or the developer that no, there is actually no. So we can just write here println and pass in the uppercase middle name or empty. So for this case, actually, you have to make your variables meaningful names so that you can understand whenever you read the code. So here we want to get the uppercase middle name. So if not, then we can just return empty or empty. So we have to understand this. Now, let's try to re-execute this. Okay, so you can see the first method, if check, the value has been returned. The method 2, we have used the safe call operator. Now this one, the Elvis operator, is the one which returned no name, because it's actually the middle name is actually null. So there is another way which is actually not a proper way to handle this, and actually can cause you crashes and throw null pointer exceptions, which is actually a big deal. So let me show you how this is going to happen. So let's call this. So we can use the null assertion. So here, for example, we can use our uppercase. We can use our middle name. And now we want to tell the compiler, hey, if this is going to be null. So for example, when we call this to uppercase, now we want to use the null assertion. So here, actually, we are going to throw an exception if, so when you use these two exclamation mark, we tell the compiler, hey, I guarantee you this value is not going to be null. And if it's going to be null, then throw an exception. So let's just copy this. So this is called a null assertion. And now let's call here println. And now you can see we're getting here an error. because this is going to throw an exception. So I want to see the exception that is going to be thrown first so that you can understand. Okay, so you can see here, we have this, which is actually an assertion that is going to be thrown. Let's remove this. Now you can see we are not getting any errors because here now the middle name is actually guaranteed not to be null. Let's just keep here. And actually, you see, again, we are getting these errors because this is actually unreachable because an exception that is going to be thrown because this null assertion guarantees us there is no any exception. Let's try to run this because now the value is not actually nullable. We know that. And you can see this method also actually works, but this is not safe. So I recommend you not to use these null assertions unless you know that the value can never be null. But this is not usually the case, so it's going to cause you runtime exception because the compiler cannot catch this. So in the previous lesson, we actually saw nullability in Kotlin. So next, let's expand upon strings. So string is actually a data type that you're going to be using more often. Let's create here a new Kotlin class and let's call this strings. Let's create here a main function. Now I'm going to declare here some variables. Let's call this first name. And actually in Kotlin, we have one thing that is called type inferences. Let's call this side, for example. Now, when you hover around, you can see actually Kotlin has actually inferred this to a type of string. So this is the power of Kotlin. Actually, it's not requiring you to write robust code. So you can easily just use this. Another case, let's declare here last name. So we have seen that concatenation, so we can call full name. We can concatenate like this, first name, and a space, and also add last name. And then when we can println, so let's println here, full name. So this is just a normal way, and actually this is how Java actually concatenate strings. But you can see here, actually string concatenation can be converted to a template. So we're going to see an example of a template. So let's look here at string templates. Let's declare here a value, for example, of message count. Let's say we have 12 messages. And here we can declare a welcome message. So we can use the same way which we used here previously. Hello. We can concatenate with the first name. Okay, so you can see this is actually going to be pretty robust and actually adding plus signs to concatenate the strings. And here, let's try to println this. And we can actually use now the string template to actually concatenate this. So similarly, let's create here a string. Let's call hello. Now, instead of adding a plus sign, we can use a dollar sign. So with the dollar sign, now we can access variables that we have declared. So we can call here first name. Then we can call here you have, use again the dollar sign, and we can call here a message count and call unread messages. So this is actually a string template. You can see this one is more readable and easier to write. So when we use this dollar sign, actually we can actually access the variables inside a string. So here we can call again println. Let's call welcome message. Now let's try to run here. So you can see we have a similar message, but here now we have used a string templates, and here we have used the string concatenations. You have seen here how to use string templates. Let's see how we can actually use common functions within a string. So common functions with string templates. So let's add here a println function, and here we can declare, for example, a string. Let's call this message. Hello, Kotlin. Actually, to perform operations. So for example, we can call here messages. but we can not use the dot operator here until we use something. So for example, when we call here dot length, you can see that we are adding here two curly braces. So 1 and 2. This way we can actually access the method of this particular class. So not only strings inside here, so we can use, for example, even to perform mathematical operations when we provide these two curly braces. So meaning that we can actually perform any type of code inside the strings here. So we can access the length. Let's press Command D or Control D to duplicate this same line. And here, for example, we can perform uppercase. You can see, let's press Control D or Command D and actually convert this to lowercase. We can actually access the substring. Let's call here substring, and we can provide a range, for example, 0 to 5 to give us that particular range. So let's change here uppercase. We can get another case. We can perform even conditional check. Does it contain the word Kotlin? So here we can change our value and call the contains as. So instead we can pass in here the value that is actually Kotlin. So this is the power of string template in Kotlin. Now let's try to run here our main function. Okay, so you can see here the first name. You can see the length is actually 12. Here we change to uppercase. Here we change to lowercase. So we can get the 5 first letter. So the 5 first letter is actually hello, which is this one here. Okay, so you can see, does it contain Kotlin? Actually returns true. That is a Boolean. So another case here, we can look at multi-line strings. So right now you can see we are just creating a single line string. What if we have a large text that we want to keep in one variable? So for example, let's create here a variable that is called a poem. How can we initialize this? Basically now we have a single line. So in order to convert this to multi-line, we have to add another these question marks here. So you can see now we have 6 of them. So we have the 3 opening and 3 closing. Now inside here, whenever I press enter, you can see we have trim indent. So this means it's the function inside the Kotlin that can remove the empty lines. So now I can add my lines. So you can see roses are red, violets are blue, Kotlin is fun, and so you are. So for this case, we can try to print line. Let's call the poem. Now we can print the poem. So this is how you can declare a multi-line string. Let's try to run here. So this is going to be the case. So you can see this here. So let's remove this trim indent. And actually, let's try to rerun this. So you can see here how the actually is going to stay because we have a lot of spaces here. So you have to use that trim indent in order to remove those lines and make it stay in one space. So remove all the extra spaces, which we actually have whenever we open up this. So we can perform even operations inside here. So for example, let's create here the username. Let's call another variable that is called Kotlin learner. We can create here, for example, greetings. Now let's create here a variable. Now we can call, for example, hello. And we can actually access this variable. So let's call here name, username. You can see we are using here string templates inside here. So welcome. And we can call the app name. Now let's try to Println here. Now let's run here our function. So this is the common functions which you're going to encounter in strings. So in this lesson, we're going to learn about Booleans. So we have seen Booleans in our previous lessons, but we want to dive deep to look at different aspects of this. So to iterate, a Boolean is a data type that actually holds either true or false. So only these two values. And a Boolean is really important when we are programming. So it's a data type that is used in making logical decisions of our programming. And actually, programmers are obsessed with logical decisions. So to declare Boolean, for example, we can easily declare variable, like, for example, is raining. And directly here, we can initialize this to a variable. So let's say this is going to be equal to false. Now, you can see here Kotlin has inferred this data type to be is actually raining. So in this lesson, we're going to learn about Booleans. So we have seen Booleans in our previous lessons, but we want to dive deep to look at different aspects of this. So to iterate, a Boolean is a data type that actually holds either true or false. So only these two values. And a Boolean is really important when we are programming. So it's a data type that is used in making logical decisions of our programming. And actually, programmers are obsessed with logical decisions. So to declare Boolean, for example, we can easily declare variable, like, for example, is raining. And directly here, we can initialize this to a variable. So let's say this is going to be equal to false. Now, you can see here Kotlin has inferred this data type to be is actually raining. Another aspect we can say, for example, is sunny. And here we can initialize directly to false or true. Let's say, for example, true. So it's raining and it's actually not raining, so it is sunny outside. So we can try to println here and we can say is sunny, and we can println here too is raining. Now, if you try to execute, this is not fancy because it's just going to print true or false directly inside here. So let's just go to our main function and try to run this. Okay, so nothing fancy. So we have true or false. So this is actually the Boolean. So if you think it directly, you can say, hey, this has nothing to do. But this one is going to help us to make logical decisions. And whenever we use it for different aspects. So for example, whenever we do any arithmetic operations, we want to use comparison operators. So for example, let's declare here my age. Let's say my age is going to be equal to 25. And also we can declare here, for example, voting age. And we can initialize for voting age to be 18. Another variable we can create here, for example, is actually current temperature. Let's initialize this to a double to be 15.0. And here you can declare, for example, freezing point. So in any program which we have to build, actually we have to use comparison operators to make decisions in these programs. So, and in any programming language, we have several types of these comparison operators. So, including greater than, less than, greater than or equal to, less than or equal to, and equal to. So, these can be used to make several decisions, and these are related to a Boolean data type. So, for example, we can say, hey, can I vote? So here we can make decision and decide if we should show the UI for the user, for example, to actually vote. So we can call my age is greater than or equal to. Using this angle bracket and the equal sign, we mean that greater than or equal to, and we can pass in here the voting age. Now here we decide, hey, this guy is actually eligible for voting. Okay, so here we have decided my age is greater than or equal to voting age. So this one is going to be true because the age is actually 25. So 25 is actually greater than or equal to 18. And now you can check here, this one is going to return a Boolean data type. Now let's duplicate this because we have another comparison operator. So let's call this convert2. So instead here of using this same logic, so we can just interchange this. Let's copy the voting age and keep it here. And here, let's keep my age. So this one is going to return false. So we want to keep this. So you can see now we are saying if the voting age is actually less than or equal to my age. So this one is either going to return true or false. So let's check this logic here. So the voting age is actually 18 and my age is actually 25. So is 18 greater than or equal to 25? So here we're just checking if the voting age is actually greater than or equal to my age. So also this one is going to evaluate to true. So these are the two comparison operators which we have right now. Now another comparison operator is actually less than. So for example, we can create here a variable. Let's call this is freezing. So here we can check if the current temperature is actually less than the freezing point. So we have said 0.0. So for this case, we can just call here current temperature is actually less than the freezing point. Now you can check here, the current temperature is actually 15 and the freezing point is actually 0.0. So to compare this one is going to actually evaluate to false. So another case here, for example, let's just duplicate this. Let's press Ctrl D. Let's say is freezing 2. So this is another variable. So we can check if the freezing point is actually less than the current temperature. So here we can say, okay, so if the freezing point is actually 0.0, so 0.0 is it less than 15? This one actually is false also. So this actually, so here, sorry, the freezing point is actually greater than current temperature. So this is another comparison operator. We're using this angle bracket here to actually check. So this one is less than, and this one is greater than. So anything that stands in the left side is going to be greater than to something that stands on the right side. So this is among of the comparison operator which we have. And this also returns a Boolean. So we can use this to actually decide in our applications. Now, another case is we said we have the comparison for equal to. So for example, we can check if it's actually boiling point. So let's say boiling point. And we can say if the current temperature is actually equal to 100, for example. So we know that the current temperature is 15. So for example, if we are heating something, now we are just having 100 degrees until we reach there. By using to equal sign, we're using the comparison operator. And if you remove this, you're just going to get an error because this is just an assignment operator and not a comparison operator. And if you add to equal sign, this one is going to be a comparison operator. Now, another case, we have another simple comparison operator is not true. So we can say is not at the boiling point, for example. And here we can use the negation. Now, when we use this exclamation mark, we want to negate that the current temperature is not going to be equal to 100. And this one is going to evaluate to true. So you can see even under, IntelliJ actually suggests this one is going to be true. Okay, so now after using these comparison operators, here we can create a println function. Let's say, for example, can I what? And here we can use a string template. And here we can call a convert. So here we can use can I vote? And we can do another println here. So let's say here we have weather freezing 2. So we can just call here weather freezing 2. And here we can check again is water. Let's use boiling point. Sorry, is it's not boiling. So this way, let's try to run here and see the output. Okay, so you can see here, can I vote, which is going to equal to true. That is our first condition, which we have here. Then again, we used this condition 2. You can see it's going to actually override to true again. And here the temperature, this one all are going to be false. So we have temperature 1 and temperature 2. And here we're checking is water boiling, it's going to be false. And here, sorry, is water not boiling. So here it's supposed to be not boiling. So this one is going to be the boiling point. So we actually use the negation by negating this. So this is how you use comparison operator to make your program more logical and provide the brain to your program. So in the previous example, we used a comparison operator to actually make decisions in our program and actually get a Boolean value that we can add a brain to our program. But sometimes our programs actually have to decide with more than one condition. So how can we combine more than one condition in order to make a decision? So in this case, we can use logic operators. So logic operators are going to combine between two conditions. So for example, we have true and false, or true or false. So mainly we have two operators, which are and or. So the mainly operator which we have, so mainly we have two operators. So this means and this means or. So let's just add this in the bracket. This means and this one means or. And another one, which mainly you can see we have used in our this one, which is called a negation operator. We can call this negation in our program. So we can try to use these to actually combine this. So for example, we previously used a combined operator here to actually say, hey, can this somebody vote? Now we can actually look, for example, by another condition. If somebody has vote and also has a ticket to vote, so we can create another variable as ticket. Let's assume this is going to be true. So inside here to actually say is allowed to vote. Now not only can vote, so here we have to say allowed to vote because we must fulfill these two conditions. So which condition? First is can vote by checking the edge. So here you can see we check the edge if it's going to be equal to the that category edge. And we can use the two ampersand to actually add another logic operator. And here we can say as ticket. Okay, so here we have another concept which is called the truth table. So the truth table for can vote, this means that it's going to be false or otherwise all of them must be true. So for this case, if any of these variable is going to equate to false, then this is going to actually mean it's going to be equal to false. So this way, false. So meaning that in order to get a true here, we should make these two variables to all be true. So our condition here is allowed to vote has to specify these two conditions, can vote and has a ticket. And if not, we want this to equal to false. Another case is, for example, we can say is allowed to stadium. Let's say we have a football match, and here football fans can actually vote for their president. So for this case, we can say somebody can be allowed to the stadium if they are actually not adults, but they should be adults to actually vote. So here it's the great candidate of using the or operator. So inside here we can check first is adult. We can say somebody who can vote. This means it's going to be an adult, or somebody who has a ticket. So this one is going to actually true. So in contrary to using two ampersands, in order to equate this one to actually be false, all of these two must equate to false. So false or false, that is going to be false. False or true, this one is going to equate to true directly by using these logic operators. So for example, let's just change this back to false. And you can see this can vote is going to equate to true. And then we can use here a negation sign. So we can say is not adult. Here, we're just negating. By using the negation operator, we can say can vote directly. So this one is going to be a negation. That is going to negate. If this is going to be true, then it's going to give us the opposite. If this is false, then it's going to give us the opposite. So by combining like this, we can just write here Println function. We can say is allowed to vote, for example. We can say is allowed Okay, now let's try to execute here. So you see, we have here is allowed to vote for president, false, because we changed this has ticket here. And also we can check is allowed to enter the stadium. This one is going to be true So here we have one force that has ticket, but this guy is actually an adult, so they can enter inside our stadium. And here we can check it's not an adult. We have actually negated this value here. So these are actually logic operators, and you're going to use them extensively in your applications. So in the previous lesson, we learned about Booleans and conditional operators and logic operators. So let's imagine that you're creating a small application that actually calculates grades from scores. And you want to print messages like, for example, excellent, you got an A, or good work, you got a B, and try harder next time. So how will you achieve this? So to do this, in your programs, you need to make decisions. So that's where we're going to use if statements. So let's create here another Kotlin class of file. Let's select file, and let's say, okay, let's create this conditional execution basics. So we have the basic structure of an if statement. So this if is just a keyword in Kotlin. So we can use if, and it's used in many programming languages. So inside here, we can pass in the condition so that we can make the execution. And now we can open these two curly braces to open up the starting and end of this if statement execution. So only the code that is going to be executed here is when this condition is going to be equal to true. So if the condition is going to be equal to true, then we can actually execute this if statement. And if not, then Kotlin compiler is going to ignore the code that is inside here. So this is the basic structure of an if statement. So let's look here at a simple example. So for example, we have a score that is equal to 95. Now we can try to check with an if statement. So if the score we can combine here with the logic operators is greater than or equal, for example, to 90. So here we specify a specific condition that we want to actually execute, and we can write a println function. So for example, now let's try to execute this code and see the output. So let's execute this because it executed a different file. So you can see it has printed here, excellent, you got an A. So this is how a conditional execution is going to actually occur. So try it yourself, change the score to 75 and see if the statement is going to print. So let's assume that we want to handle another possibility. Let's say here, this one is going to be 25. So the student scored 25, and see if we can actually handle a lowercase. So right now here, when we try to execute this, you can see that nothing is going to be printed. So our program didn't print anything in the console. So we can use an else block, which executes only if this is not going to be true. So here we execute if it's true, then we can pass in this here. So here we can just write a println function and say, keep going. So right now, let's try to re-execute again. So now you can see we have printed this. So keep going, you can actually improve. So Kotlin is going to choose one path, either if or else, and never the both. So for this case, we can execute one of these conditions, but not both conditions. Okay, so realistically, in a real world, we cannot just rely on one score. So we have to use multiple conditions in order to check this. So for example, we have here the score. Then we can try to check if it's going to fall in different categories. So we can check if the score is going to be in 80, 70, 60, and actually provide a grade. So here we can use another if statement for multiple grades. So we're going to use the else if. So here we can use else and actually provide another condition by using an if else if. So inside here we can pass in the score. So if the score is going to be greater than or equal to, for example, 80, now we can print here another statement. So let's just println and say, for example, grade B. Again, we can chain multiple conditions. We can use else if, and if the score, if it's going to be equal to 70, we can say, for example, grade C. We can chain another one. And here we can use, for example, score is greater than or equal to 60. And after all the executions, now whenever a student falls below 60, then we can print, for example, this one is going to be an F. So else, so any value that falls below 60 is going to actually execute this. So we can write here Println function. So grade F, you can do better next time. So here is how Kotlin is going to execute. So it's going to start from top to bottom to actually look to a condition. And if it finds, for example, this condition here actually is true, then it's going to ignore all the rest of this. And if not, then it's going to traverse through all the conditions which we have provided here and actually print. So because our score is 25, let's try to execute here. So you can see it has printed this grade F. You can do better next time. So it traversed through all conditions and actually found this one here to be true. So let's change this, for example, to 75. Let's try to re-execute again. You can see it's going to fall on this range here of grade C. So guys, this is how we actually chain the conditions and we say the order matters. So Kotlin checks from top to bottom and stop at the first true condition that is going to actually fall on the else if conditions. Now, sometimes we have to nest if statement. We can nest if it's actually necessary. So don't just nest if a statement inside there. So for example, sometimes one condition depends on another. For example, a student might get a bonus if they actually have a perfect attendance. So let's introduce here. We can say has perfect attendance. Let's assume this one is going to be true. So we can check here, we can nest another if statement inside here. So we can check if, so let's just go inside here and nest another if statement. Let's copy this. Let's paste it here, grade C. Let's copy this. So now let's try to re-execute here. You can see we have printed this grade C and good attendance because here the attendance is actually reflected to be true. So actually use nesting sparingly. Too many layers make the code harder to read. So for example, if we add another if a statement here, so you can see if then a score maybe is greater than or equal to 70. So you can see we have a lot of if statement that is going to be inside here. So our code is not going to be perfect to read and easier to read. So we should do this and avoid and use when necessary if we want to nest if statements. Okay, so in Kotlin, we can use an if statement as an expression. So let's collapse this first. Okay, so in Kotlin, we can actually use an if statement as an expression. So instead of printing directly, we can just store the result of an if inside the certain variable. So for example, we can have here the score we had there. So now we can declare here another variable and call this grade. Now directly here, we can use an if statement and check. So this one is the syntax of Kotlin. So let's call here, for example, score. If it's greater than or equal to 80, for example, we can just return A. So this one is going to actually return and check else if. Okay, so you can see we have here a grid, and this option is actually much more cleaner than how we used here. So you can see we printed directly here. So we can actually reuse this grid variable in different places. So this is actually much more cleaner. Now inside here, we can try to Println, for example. Now we can use it differently. So we can say the grid is, and use the string template and actually call the grid. Now let's try to re-execute again. So you can see actually the grade is B because here is our score. We have said 75. Okay, so here we have used only a single condition to actually make decision in our program. But actually we can combine this by using the logic operators. So we said we had several logic operators. So we can use an if statement. So for example, if score is greater than or equal to, for example, 70, and we can add two ampersands. So this one is going to actually combine two conditions and has good attendance or perfect attendance. Then we can say, hey, you have done this. So Println to end a certificate. And else we can just say, for example, so for this case, we have used the score and actually combined this with a perfect attendance. And here it's going to execute this only if both of these two are actually true. And if not, then it's going to execute this as a block here. Let's re-execute again and see. Okay, so now our student has actually earned a certificate because they have the perfect score and actually attended. And we can actually use if either of these. So for example, let's duplicate this. Let's press Command D or Control D. Now, if the score is actually, for example, greater than or equal to 90, so this is an exceptional student, and here we can use or a logic operator. So here, either of these should be true, then we can say the student has earned a certificate. So if this is going to be true and this one is going to be false, but they have actually achieved this, and actually we can say you have earned the certificate. So in the previous lesson, we used if statements and we used many of them. But actually, this is not elegant. So you can see here, our code is actually not looking perfectly. So Kotlin actually gives us something better, the when expression. So this is going to be like a smarter switch, a statement that can check values and ranges and conditions and different aspects. So for this case, let's create here a new Kotlin class or file. Let's call this when. Let's create here a file, create a main function. So a when statement has a basic syntax, so we can use the when keyword. And here we have to pass in the value. So the value of or something that we want to actually check. So for example, for a case, it's going to be a score. So inside here, we can use the option one. So for example, option one, then we can use this arrow to say, hey, if this option one is going to be perfect, then we can do something. Similarly, if we have another option, so we can say, for example, option 2, and open up this and actually do something again. And if all of these options are not, then we can use an else and actually perform. So this one is going to be our way. So here we can say, for example, do something again. So this one is going to be the default case. Okay, so let's wrap this. So this is actually the simple way of actually declaring our when statement. Let's collapse this. So for example, we can declare here a grade and actually make Kotlin to actually check this. So for example, we can have a variable that is called the grade is equal to B. So now we can perform the condition by using the when statement. So we can say, for example, when grade and check first. So we can say A. So these are the possible outcomes which we have. We can say Println. Excellent. We can check B as in here in Println. So we can say good job. Again, we can check here C. And we can use now the else block to exhaust the when statement. And here we can pass in the println and say, we can try to println. And so we have already used the println here. So for now, let's run here our code. Okay, so you can see we have used the grade B. Now we have our when statement. Actually execute this. So actually Kotlin is going to check each branch top to bottom and stop when one matches. So for this case, all of these conditions Kotlin did not check because this condition actually evaluates to true. So only one condition is actually needed to execute this. So you can see the difference here. So we used here when statement simply. You can look at the conditional basics, which we did here. So you can see this is just a similar of using this else if statement here. But now we have a shorter code, more concise and readable code. So everybody can easily understand that if A, then we print excellent. If B, good job. Okay, now this actually is a similar way which even Java can have a switch statement. Now, let's look at the power of when statements. So we can use when statement differently. Let's come here. Now we can use when statement with range. So in Kotlin, we can have a range, for example, from 90 to 100, 80 to 89, and different ranges. So let's create here when statement. Let's create first the variable that is called score. So let's say the score is actually 82. Now let's create here a when statement. And here let's pass in the score and check. Now we can check in by using the keyword. We can use this in, and this one is going to check if it's going to be inside this range from 90. Then let's use dot dot to 100. So you can see here even Kotlin or Intelj suggested that if 90 is actually within this range here, then we can open up here. And if you have a lot of block of code, you can actually use the curly braces here. So for example, if you had to do other conditions, then you can open up these curly braces and actually execute. Let's create here, for example, the println. Then we can check another range from, for example, from 80. And we can do the println. So the curly braces are optional. So here we can say, for example, so we have here the grade system. You can see the ranges. And actually, the range, for example, in 90 to 90 checks if the score is within that ranges. And ranges are actually inclusive, meaning that the range, for example, from 90 to 100 include both 90 and 100. And another thing which we have here is you can see if somebody does not pass within this range, if, for example, our score is 200. So this way we can print this else score because it's not within the range that we have specified for a case. So let's come here above and execute this. You can see we have printed this invalid score because this score is not within our specified range that we have. So here, for example, 82. Let's try to rerun again. So you can see now it has printed grade B because 82 falls within this range here. So this was one way of using if statement. Now we can include multiple conditions in one statement. So as how we used if. So you can see here in if statement, we actually used two conditions to actually print something like this. So let's go inside here, when statement. So we can use here, for example, a when and pass in the grade. Now we can check if this grade is going to be A. And when we use a comma here, or it's going to have B, then we can actually say here. So you can see our syntax is going to be shorter. We can write here println, you passed. So again, here we can use, for example, C, comma D, and even we can include here another condition. So we can just keep going. So you can write here Println. For example, you failed, or we can have here another one, maybe yes. So you can see we can pass in here the conditions. So let's just remove the F and keep C and D. So we can just keep adding here the conditions. Let's say F with log red, for example. And we can use an else block. Let's say invalid. You can see we can check these conditions here because we have our grade. We have said this is actually B. So now when we try to execute again, so you can see we have this passed. So let's assume we change our grade to something like X. So you can see invalid grade. So another way of using an if statement is actually to use it without an argument. So you can see here we use the when statement together with a variable inside here. So another way we can use, for example, when, and directly here we can no need to actually specify a variable and actually use a conditional execution. So this one is going to be pretty similar to using like this. So with this, we can pass in the condition directly here. So for example, you can say score is greater than or equal to 90. And even we can use, for example, the as good attendance. So let's create here another variable. Let's initialize this to true. And here, basically, we can just combine with this. Let's perform a Println function. And we can say, for example, excellent. And if the score, for example, we can check is greater than or equal to 80, for example, we can do a Println here. So we can say very good. And we can use an else part. So this is similar to using if statement here. Now we can pass in here the Println function. And we can say, let's try to re-execute this and see. Okay, so you can see we have very good because here our score is actually in 82. So it's going to fall in this range here. So another case is using a when statement as an expression. So you can see, for example, inside here, we use the score. So let's just copy this, press Ctrl C. Let's go below here and use it as an expression. We can just print it here. Let's create a variable and let's call this, for example, grade. And we can directly initialize this here. Okay, so now when we want to edit a massive piece of code, so for example, here we want to change this. So let's change this variable just to be grade 1 because we already have a grade variable. So when we want to change a massive code like this, so we want to return a value. So we can easily do this by pressing Shift, Command, and Option, or you can press Control, Shift, and Option in PC. So for this case, you can just put the cursor here. So let's first remove this cursor from here. Let's press our cursor here and press Shift, Command, and Option. Similarly, now we can click to add multiple cursors. Now we can highlight this, all of these, by pressing, for example, Shift and Command and delete. Now we can just add like this. So this way we can pretty much refactor our code easily. So here, for example, you can say A, B, C, D. Let's remove this one condition. And here let's pass in F. So with this way, we have our condition easily and we have refactored our code. Now let's write here Println function and you can say you got, and we can use our string template and call the grade 1. So as easy as this, you can use a when statement as an expression. So you can see the result of this is going to be assigned to this variable here. And you can see even with complex types, Kotlin is actually going to infer the type. So you can see this is going to be of type string here because we passed here. So in the previous lesson, we have learned about conditional execution and we have seen if and when statements. So right now, let's focus on loops. So we can create here a new Kotlin class or file. Let's select Kotlin class. Let's call this for loops. And inside here, let's create our main function. So imagine we have 5 students and we want to grade them. So the easier thing we can do to print here and say grading student 1. Now, because we have 5 students, we can actually duplicate this. So we can press Command D 5 times. So here we can grade and 5 students. So pretty easy, pretty straightforward. Now, should we have 50 students? Now we'll have to copy and paste 50 students and actually print them. So typing or copying that by many lines of code is going to be boring and actually error prone. So this is why for loops were invented. So a for loop lets the computer repeat the code automatically. So we can give it a range. We want 50 students. So in all of these 50 students, you can do this. So that the syntax in Kotlin is really straightforward. So we can say for. So the for keyword is going to be used for creating loops. So we can say here that is the variable which we are going to declare and use it inside the loop. We can use the in keyword to actually say, hey, we have this. And here we can provide the range. Now inside here, we can use that variable. And here, the code that repeats. So we can say, for example, print this variable or do anything with that variable. But we have a range from 1 to 10, for example. So this is the basic syntax of for loops. So let's add comments here. So for example, let's assume we have 5 students and we want to actually repeat the same what we have done here. So what we can easily do is create a for. Now we can say we have I, that I is going to stand for index or number. So it's a naming convention. You can use any type of data. So we can use a range 1 to 5. We have the inclusive range. And inside here, we can write our println function. Let's say grading student. Now we can use the variable which we have declared here. So you can see this is the variable and you can see as this is highlighted here. So we have not used that parameter. So for this variable, here we can use the $sign and use I. So this piece of code is going to be similar to what we have printed here. Let's try to re-execute. So let's add here a println function so that we can differentiate this. Okay, let's come here and select this and run our code. So here we used the type and the pasting of our grading manually. And here we're using a for loop. So you can see the code is similar, but here we just wrote one println function. So this one is going to loop again and again until this condition is going to be false. So it's going to start 1 to 5. As you can see here, it started. So this is going to be our loop. So each time the loop actually runs, Kotlin automatically is going to increase the I by 1 until the condition is going to reach. So you can see here loop solves a lot of problem. Let's say we want to change here grading student 1 in, for example, we say in class 1. So what we have to do here, for example, here we have to call in class 5, for example. So we'll have to make changes to all of this. But this is not going to be the case for the loops. So for the loops, we can just come directly here and make the changes here. So you can see this one is going to be pretty much awesome because we don't have to modify different places for changing our code. So here directly you can see we have modified a single line of code, but it has affected in several outputs which we have. But here you can see we have affected only one. So we'll have to copy and paste all of this. So this one is going to be error prone and actually pretty tedious. Okay, so in Kotlin, loops are actually pretty powerful rather than Java. So in Kotlin, you can use, for example, steps. So let's assume that we want to print only even numbers. So there are several ways to actually achieve this, but one way is actually using a step. So we can say, hey, loop, in every range, you have to skip certain number. So let's declare here, for example, a for loop. So let's declare here a variable in, and actually we want to start, for example, 2 to 10 actually. So from the range is starting 2 until 10. And then we can actually tell it to give it a step. So by using the step keyword here, we can say we want to skip 2 so that we can actually print the number. So let's do this println. And here we can use the $sign and use our variable. So now let's run again. So you can see the even numbers. Let's add here another println to actually. So here we have the step loop. By using the keyword, we are telling it so that it can start from 2, then skip 2 variables. So here it's going to print the next variable, that is 4, 6, 8, and 10, by skipping every second number. Another case is you have a loop that you want to count from starting, for example, 10 to 1. So you want to actually go back 1. So for this case, we can create here counting down. So let's create here a for loop. We can start I in. So we can say 5. Then we can use down to keyword in Kotlin and say down to 1. So we are starting from 5 going to 1. So pretty much here we can just print and say. So we are counting down to new year. So basically here we can use I. And after that, so the loop is going first to execute the code that is going to be here. Then after that, it's going to actually execute the code after this. So for this case here, we can try to println here and say Happy New Year. So first it's going to loop 5 times. Then after that, it's going to actually print this. So let's try to re-execute this. So you can see here it's counting down to New Year 5, 4, 3, 2, 1. Then it's going to print this line of code here. We can actually combine for loops with other conditional execution like an if statement. So for example, we can make our grading system actually more smarter and actually easier to maintain. So let's create here a for loop. And inside here, we can say we have a student. So we are assigning here a variable. And for example, let's assume we have maybe 20 students. Now for every 20 students, we want to actually calculate their scores. So let's we can assume here our student. Let's go with just 5 students here, for example, plus 10. So we multiply by 10 and plus 30 so that we can get a variation of score. So for this case, the first student here is going to have 10 plus 30, that is 40. Then the second time we loop again, this one is going to be 2. So the student is going to be 2. Then it's going to take 2 multiplied by 10 plus 30. So that is going to be 50. So it's going to repeat this until it reaches 5. So inside here, we can use an if statement. So we can check if the score is actually greater than or equal to 50. So this is just an abstract example. But when we use, for example, a collection, so we're going to study this, we can use loops in much more powerful way because we're going to have a collection of items. Then we can loop through all of those items and actually do something meaningful. So this is just an abstract. So inside here, we can just use the println. Let's say here, student. So we can use the student number. That is actually the student scored. And here we can use the score and say if it's actually greater than that, and we can use an else statement. Now let's use here a println function. So we can say, and we can use the student number. Let's use the $sign and pass in the score. And here actually failed. So as simple as this. So we can use here. Let's add another println. So you can see here we have the loop with if. So student 1 scored actually 40. So the student 1 actually is going to fail. Then the next student is 50, 60, 70, 80. So as simple as this, basically we can loop through this and actually perform other actions by combining them. So we have nested here loops with if. So you can see we have used an if inside the loop. And also we can nest loops inside loops. So we can actually nest loop inside loops. Let's create here, for example, another example for I. And we can go 1, 2, 3. Let's go to 3, range, small one range. So we can loop first 3 times and actually create another loop that is going to loop. So let's create here another loop that is called D. Let's use J in 1, 2, 3 also again. So inside here, we can do a print function. So let's just use a print, not a Println message. Now inside here, let's use, for example, I. So basically, we are looping the first time. So when we loop here, we're going to go to this loop. So this loop is going to loop again 3 times. Then again, we're going to go 3 times. So let's create here another Println, just an empty Println, so that you can see the output. So inside here, let's just, okay, now let's execute this. Now let's add one print here and give it a space. Let's re-execute. Okay, so you can see here we have created a simple table. So this is the nested loop which we have. So we are first looping here and I'm printing this first row. So you can see this first row. So when we are starting one, so here it's going to be 1 also. So it's going to print 1, 1. Then again, it's going to go 1. This one is still in 1. So I is 1. Then here it's going to be 2. Then it's going to 3. After we finish 3, then this one is going to increment to 2. So you can see here we have 2, 1, 2, 2, 2, 3. Then again, it's going to finish. So this is the nested loop. This one is going to be pretty much handy when we actually work with table and also working with grid system. So this is called the nested for loop. Okay, so now let's call this break. So we can create a loop, for example, that loops in a range of 1 to 10, for example. Now we can pass in here a condition. So we can say I. If I is going to be equal to 5, then we want to break. So this one is going to stop completely the loop. As we have seen, our loop actually prints continuously. So we can print here I until it finishes its range. But now we have this condition. By using this keyword here, break, then we're going to terminate this loop and proceed with the next line. So here we can write a Println and say after. Now let's re-execute again. So here we are starting the break. We're going 1, 2, 3. Now it reaches 5. Now it's breaking. Then it's going to execute the code after that. So this one is really important when we are using loops and actually to understand the break. So another case is we want to actually pause in a certain condition, then proceed with the rest of this. So we want to keep going. So let's copy this and paste it here. So this one is going to call continue. Let's create a loop again. So let's just copy this loop. We are going to 1 to 10. Instead of using break, we can use the continue keyword. And let's call this copy and paste it here. And after continue. Now let's try to re-execute again. So we're calling continue. So we're going 1, 2, 3, 4. Now we have hit our condition that if I is going to be equal to 5, then we want to actually pause on this and proceed with the next item. So it 1, 2, 6, 7, 8, 9, and 10. So as easy as this, we can actually achieve the case. So in the previous lesson, we have seen how to use loops. But currently, we have been hard coding our values directly in our code. But this is not actually really programs what they actually do. We usually get inputs from the user. Like our IDE here does not hard code the values directly, but we actually give them inputs. And this is the input which I have set inside my program. So how can we actually achieve this using Kotlin? And it's going to be really simple. So in Kotlin, we can create here a Println function, for example. We hard code here the value, for example, enter your name. So here we want the user to actually enter their name. So how can we get this? And in the years of 90s, people actually used the console application directly rather than actually using the graphics like how we do now. You can see I can access here the button to actually click, and under the hood is going to execute the commands. But now, previously, we actually used the command line to actually interact with our system. But for now, we can try to actually mimic this. For example, let's say name. And here we want to get the name from the user. We can actually use a readln function. So we have this readln function is actually going to read directly by now here we have the username. So we can try, for example, to print here and write hello and use the name. So this is as simple as this. We have the user input. Let's try to execute this. So our program here wants us to enter the name. So whenever you press the cursor here, let's say Said. And whenever I enter, you can see it's going to say hello, Said. So as simple as this, now we are interacting with our console. So by default here, the readln function is going to return a string, which can be, for example, a string or null. So for example, or empty. For our case here, it's going to return a string. But sometimes we want to actually get numbers from user. So how can we actually do this? Let's say, for example, we have another variable. We want to get the score. So enter your score. We know the score, this must be in terms of, for example, integer. Can you guess how can we do this? Basically, we can just call here our readln function and call to. Now we can try to use here println function and pass in a score here. Now let's try to execute. Okay, so our program wants us to enter the name. Let's say Said. Hello, Said. Now enter your score. We can say, for example, 50. Now it's printing 50 here. So this is actually, we can try to use a conditional execution here. For example, let's use an if statement. We can say if a score is greater than or equal to 50, for example. We can try to write here println function and say, hey, you passed. Else, we can write here println function and say you failed. Now let's re-execute again. Okay, so here it wants to enter our name. Let's say Said, enter score 50, and you can see we passed. So this is how you actually guess input from the user by using the readln function. So in the previous lessons, we have seen different types of loops which we have used. So a for loop is actually really crucial in using in repetitive tasks. But sometimes a for loop actually needs a predefined condition that we know we have to loop 5 times, then we can just move on. But sometimes we don't know how many times we should loop through that. For example, if we're downloading a file, a download speed can be different. Then now our file can take more times. So how can we actually let the user know that, hey, our file is actually downloading? Basically, we have to use another form of loop. And here comes the while loop. So in Kotlin, we have a while loop that is using the keyword while. So here we have to pass in the condition that must be met so that we can execute the body of this while loop. So inside here, we have to execute the code. So this loop here must actually meet this condition so that it can execute this code. So let's just add a comment here. Okay, so that is the body of the condition. So for example, in a normal loop, you know that you have a count of 5, for example. Now we can use a while loop. We can say whenever the count is going to be greater than 0, then we want to actually execute this piece of code. So for example, we want to write, for example, countdown. And here we can pass in our count. So we want to count down from 5 to 0. But here we want our count to actually execute this. And if we do not change this count here, we're going to have an infinite loop. An infinite loop is the loop that never breaks. So for example, you can see here we have our count is 5. So meaning this condition is going to always be true. So you can see even understood here is highlighting us. This is going to be equal to true. So you must be careful with while loop because they are going to cause you infinite loop. Let me demonstrate this. Let's try to run this program here. Okay, so you can see our program is running infinitely because there is no condition that is going to actually break this loop. So now let's press this red button here to stop this program execution. So how should we actually break this? So we have to actually change the count. So for example, we can use this count and we can use this decrement operator that is going to actually remove 1 by every iteration. So now re-executing this file, you're going to see the difference. After 5 times, then it's going to break the loop. Now you can see starting from 5 until it reaches 1, because 1 is actually greater than 0. Okay, now let's see at a simple example of how you can also use a while loop. So let's declare here a variable that's called total file size. Let's initialize this to 100. Let's say we're downloading total file of 100 MB. Now we can create another variable that is called download speed. This can usually change in real world, for example. But for us, we're just going to hardcode this to 15. Let's say again we have the downloaded size. By default, we are starting from 0. Now we can create here a Println function and say, for example, starting downloading. Now we can use the while, and here let's specify the condition. So the condition is going to be if the downloaded file size is less than the total file size, then we have to proceed. So we have to execute this piece of code inside here. So we can say, let's give the feedback to the user how much has been downloaded using the total file size, say MB. Now, if we leave this as how it is, then we are going to have an infinite loop. So for example, because an infinite loop occurs whenever this condition does not actually change. So if you try to execute now this piece of code here, it's going to actually execute infinitely until we have to actually change this. So for this case, we have to change our downloaded file size. And here we can use an increment operator that is called whenever we add a plus sign and equal sign, then this value is going to be added to this. So for example, we are going to have the downloaded speed. So our downloaded file size is going to add the download speed, which is 15 every time here. So our value is going to be changing. You can see now even Android Studio removed that warning of infinite loop here. Now, after we finish to actually download, then we can actually print to the user. Now it finished to download, so we can say downloaded completed. Let's try to execute this piece of code and see. So you can see it's starting download, then it went to 100. So let's do one thing, because here we're not seeing how it's changing incrementally. We can try to use a thread. So we can strip this thread so that we can mimic how a real world download file. So let's use a thread that is in Java. And let's call .sleep so that we can sleep this by, for example, let's go 500 milliseconds, which means half a second. So now whenever you execute this piece of code, let's rerun again. So now you can see it's going incrementally until we finish to 100 and then download complete. So this is how actually while loop are used in a real world. Okay, so let's play through with another example. So we want to create a program that is going to tell a user, for example, to guess the secret number between a certain range. So let's say between 1 and 10. And then the user is going to actually make a secret number. And if not, then we have just to loop again and again. So you can play this with anybody. So don't show them the secret number. So for example, let's create here a secret number. And here we can initialize this to 7. Then we can have the guess, which the user is going to actually guess directly. And this one is going to be of type int. Now let's write here a println function to let the user know. So let's tell them guess the secret number between 1 and 10. So here we can call our println function. Let's call guess. And here we're going to call the readln and change this to int directly. Now we can use a while loop. And this is one of the major use of the while loop because we don't know how many times the user is going to guess. So for this case, we cannot use a for loop to keep on repeating the task. So we want to repeat the task until the user gets the number correctly. So we can say if the guess is not equal to secret number, keep looping. And we can open up here while loop. Let's use a simple if statement. Let's check the guess. If the guess is less than the secret number, we want to give a hint to the user. So let's write here a Println function. Let's say too low, and else. Let's just copy this. Try again. Now we can just copy this value here, paste it here, and also let's copy this, paste it here. So we'll keep looping again and again so that we can hint them again with these values here. Now, after the user actually gets, we have to give them feedback. Hey, you have done this correctly. So we can write here Println function after and say congratulations. You have guessed the secret number. And here we can use the secret number. So as simple as this, we have our program now running. Okay, so I don't want this one to actually crawl. Let's use 100 milliseconds. Let's try to rerun. Okay, so it's asking us for a number. Let's place, for example, 2. And see, it's hinting us 2 row. Try again. Let's go for 5. Again, it's hinting us that too low. Let's go to, for example, 9. Too high. So we know our value is between the range of 5 and 9. So we can just loop around that. So if we go 8, too high. If we go 6, too low. So we know the only number remaining is 7 here. Let's go with 7. Now, congratulations, you have guessed the number 7. So this is how we use a while loop to play this simple game. So enjoy with your friends. So in the previous lessons, we have seen how to use a while loop. So a while loop is going to execute the piece of code inside here if this condition actually evaluates to true. So this sometimes is not the case. We want a code to actually execute even once before proceeding to the condition. And now you can see here we're just cluttering our values outside of the while loop because we want this to actually run even once. So you can see we're duplicating this code here. So you can see we are duplicating actually this, for example, this guess inside here. And again, we're duplicating it here because we want this code to run even once, even if this guess is actually not true. So we want to execute this piece of code even once. So there is another form of while loop that is called a do while loop. So a do while loop is going to execute the piece of code even once, even if the while is not going to be equal to true. So the syntax of this is actually creating a do. And here you have to specify a while and pass in the condition. And here is the condition which we're going to pass. And inside here, now we have the code that runs even once. So this is the syntax. Now let's just add here a comment. So we can try to refactor the same code which we have done here by using the while loop, for example. Now we can create a do. Now let's just copy this. So we can create our Println function and the guess, readln. We want this code to actually execute even once. Now we can just copy the code which is inside here. Press Ctrl C. We're not going to take these 2 lines of code because they already exist here. Now we can just paste it here. So this is the condition which we want. Now we can use a while in order to declare that condition for looping. So you can say if the guess is not equal to a secret number. Now for this case, our code is going to actually execute. Now we can also copy this. Let's copy this congratulations message, which is going to be done over here. So now you can see our code is actually neatly organized. So we have the do, which we know will execute even once in this loop. And now we have a while. This is the condition which we have. Then we are going to execute a code after this loop. Now, if we try to re-execute again, first let's just keep here a println function to actually say do while loop. Let's rerun again. So this is the first, which is using just the normal while. Let's pass in 7 here to terminate this. Okay, so now we have the do while loop. So you can see we have guessed the secret number. Now we are just executing this piece of code inside the do while loop even once before even checking this condition here. Now we can start to check the condition and looping. So for example, let's say 5. You can see too low. We can say 3. Now we did not duplicate this checking here, for example, the Println and getting this value, but we're still adding here. Let's say we go to 8. Now we have our too high value. Let's go to 7. Now we have our congratulation message. So as how we have seen here, a while loop actually checks the condition. If the condition is true, then we'll keep on repeating that loop. And if the condition is going to evaluate to false, then it's going to stop that loop. In contrast to do while, the do while actually runs the code inside the do first, then checks the condition. If the condition is going to be true, then it will keep on repeating the code execution. And if not, the check actually evaluates to false, then it's going to stop that loop. So far we have learned a lot of concepts. So we want to actually combine all of these concepts and see how we can create a really program that is going to be our simple contact book. So this is simple contact book is going to give us two features. The first is view all contacts which we have saved and also add a new contact. So we're going to combine different aspects of what we have learned. Okay, so by starting, I'm going to create a contacts book. So here it's going to be like our storage. In real world, you're going to use a database like a SQLite or even a server that you're going to save your data. But for us, we're going to use in memory. And I'm going to just skip you to one step further. That is actually storing a list of things. So for example, we have been using strings, booleans to store a single item. Now, let's say we have more than one item. How can we save them and actually later use them? So for a case, we're going to have a list, and in Kotlin, they give you a simple data type that is called a mutable list. And here we want to declare a mutable list of strings because our contacts are going to be in form of strings. So this way we have initialized a list. Now we can create another that is called the user choice. And the user choice is going to be of type string. Now we can use a do. And inside here, let's create a println function, for example. So this is the name of our program. Now we can show the option which the user have. So we can create a println function. Let's say number 1. You can view. Let's duplicate, press Command D or Control D. Let's call this 2. And here we can say add a new contacts. And option 3 is actually exiting. So we have these 3 options. Now we can actually hint the user. Let's write here a println function called enter. We can use a when statement because we're going to have 3 options. So we can call here our user choice. Now, if our user choice is actually going to be 1, okay, so we have not initialized here our user choice. So we can call user choice and use a readln function in order to read this. Okay, so now let's open up here our code execution file. Said here, our first condition is going to be a viewing all contacts. So inside here, we can say, so we can call our contacts because this is the list. We have a built-in function that is going to check if that list is actually empty. Now we can hint the user, hey, you don't have anything inside your contact book. So you can say, so the user is going to know what to do. Else, now we have a list of more than one item. So this is the particular use of a for loop. So we can loop through around a list and actually print everything as how we need. So let's just call here our for. Now we can actually access this in a different way. So we want to get the index and the contact. So this is the destructuring. Inside a list, we actually save an index that corresponds to its value. And this index usually starts from 0. So we have a 0 item that corresponds to item number 1, then 1 going to correspond to item number 2, until so forth. So for this case, we can use in keyword and call our contacts. And our contacts here, we have to use with index so that we can get that index. Now let's open up here our curly braces. Now inside here, we have access to our index and our contact. We have destructured it. So inside here, we can say, for example, let's call our index, and then we want to plus this by 1 because the index by default is going to start from 0 to get that first contact. So if we have more than 1, then we can just keep adding here. So this was the first option. Let's go to our second option. Okay, so this second option is actually we want to add a new contact inside here. So let's write a println function. Let's say we can hint the user, hey, we want to get the name. So let's call int name. Now for a case, we can create a variable called name, and we can call our readln function here. Then let's println to hint the user to enter. Let's call our number, and here we can call our readln function. So now we are reading here the number. We can check. First, we want to code defensively because we don't know how the user is going to actually enter the name. So sometimes it's going to be blank. And we want to tell, hey, this is not a valid thing. So we can create here a name. It's not blank. It's blank first. We want to check. Or if the phone number is actually blank. So you can think a lot of things. So for example, if a number is not in a certain format or the number is less than this, you can tell the user, hey, you have done something. But for a case, let's keep it simple by just checking these things. So let's create here a println function. And here we can let the user know error and phone number. Now else everything is perfect for a case we want to save here. So we can create a new contact. We can use the name, for example, and pass in the number. Now we can call our contacts so that we can add to the list. We can call the add function here. Now let's call here our new contact. Let's hint the user, hey, you have saved the contact successfully. Now this was our second option. Let's collapse this. Let's place 3. Now this is our last option, which we want to actually close. So we can write here a println function and say closing. Okay, so we have finished here our user choice. So you can use this arrow here to collapse and expand this. Now we have to pass in here our while condition. So our condition, if the user is going to actually select 3, then we have to actually cancel this. So we can call here our user choice if our user choice is not equal to 3. So we have to keep on repeating. Now, after we finish this, we can say println. Let's say goodbye. Let the user know. So as simple as this, we have our simple contact book. Now, let's try to execute these contacts. Okay, so our contact book here is opened. Let's press 1 here to view our choice. You can see your contact book is empty, so we have to loop again. Okay, so we are still in the program. Let's create here 2. You can enter the name. So the first name, let's say Said. Let's say phone number 12345. Let's enter. Let's add another contact here. Let's say, for example, Wood Lab. Enter. let's add the phone number 23456. Press enter. Now let's look at our options which we have. Let's press 1, enter. And now you can see here our contacts are printed. So we have the name and the first item and the second item. Now let's use option 3. We have already finished. Let's press enter. Now closing contact book and saying goodbye. So this is how we actually combine different aspects to create a meaningful program that actually thinks. And here we use an in-memory list to save our data. So if we use the database, then our database will be persisted. So guys, in the previous lessons, welcome back. So in the previous lesson, we have seen how we can combine different aspects by using do while, when, if a statement, and a list to actually display a simple contact book. Now we want to look at another concept, the concept that is called functions. So you can look here at our main function. So you can see we have a main function like our main entry point. And here our code is actually not readable. Everything we are crattling inside the main function. So this is not ideal because everything is kept inside here and we cannot reuse the functions. So for example, here we have the user choice. You can see everything is kept inside here. So we can try to keep the code in a different function by creating our custom functions. So in this lesson, we're going to look at functions. Now just create a new Kotlin class or file and name it functions. Then we're going to see. So for now, let's say, for example, we have an order application. We can say, for example, we have the subtotal. So the subtotal here is going to be 44.50, for example. Now this is the total cost of all the foods and drink, for example. Now we want to calculate the tax. So this was our first part. So let's say part 1 was actually define the order subtotal. So we had the subtotal from the user picking items. Now we have the part 2. Now here we can create a variable. Let's call this tax rate, for example. And our tax rate is going to be 0.08, let's assume. Now we can get our tax amount from this. We can call our subtotal multiplied by the tax rate. Okay, so everything is perfect. Now let's look at the third part, so part 3. So inside here, we want to calculate a tip, for example. Calculate tip. So how can we calculate the tip? Let's use a tip %. This one is going to be of type double. Now we can check if, for example, a user exceeds a certain value, then it's going to tip a larger bill. Or if not, then it's going to tip a smaller bill. So let's just assume this if our subtotal is greater than 50, for example. Now this guy is going to tip us 0.2, for example. So here we have a good service on a larger bill, and else a good service on smaller bill. So we can say 0.18. This is just an assumption. Okay, so we have calculated here our tip amount. So let's call this, it's going to be equal to subtotal multiplied by tip %. Now we can get the grand total. So this is, so here we're going to take the subtotal plus the tax amount plus the tip amount. Now we want to display the bill to the user to actually know how they have calculated. So here we have the part 5. Now we can create here a Println function. Okay, so inside here, I want to format our data by using only two items. So only 2 decimal points. So to do this with the strings, I'm going to use a string template formatting. So we can use a percent and use the 2f. So this way, it's going to round all the values to only 2 digits. Otherwise, it's going to give us maybe 7 or 8. Scroll dot format from our string. So this is a string function that uses this string as a format string and return a string obtained by substituting format specifier in the format string. So we have specified this. We want only 2 decimal points. And now we have called dot format and pass in here, for example, our subtotal. So let's print again. Now we want to get, for example, the tax. Let's duplicate this. Let's say tip. Okay, let's just copy this and paste it here. Now we want to display the total. Let's call this total. And here let's call run total. So this is the simple way of actually displaying this. Now let's execute here our main function, and you can see. Okay, so everything, I think here we have to remove not many. Okay, so you can see your restaurant bill is this one. We have the subtotal, we have the tax, we have the tip amount, and now we have the total, which arises here. So everything is looking perfectly. But when you look here, we have a lot of things, and we can actually extract some of the things to a separate function to make our code more readable and actually more maintainable. So now we can actually, for example, let's just leave this. We can come below here and actually create a new function. So let's first calculate the tax. Calculate tax. We can create here our function. Let's use the fun keyword to denote the function. Now we can pass in here the function identifier by calling calculate. So the functions actually, let's call this calculate tax. It's going to be similar to how variables we have. We cannot use the keywords that are going to be used by default by Kotlin. And here, let's call this bill amount to get the parameter. So we have the functions that can take in parameters. And here, this is going to be of type double. Now, this function accepts a parameter, and also it needs to return a parameter because it has to do the calculations, then give us back the result. So how can we do this? We can use this 2 colon to denote that we want to receive a double as our return type after the function execute the code. Now, here we can have, for example, the tax rate. So our tax rate is 0.08. Now we can just return here our bill amount. And our bill amount is going to be, bill amount multiplied by the tax rate. So we know that we have done this function. Now, if the user reads this, knows that this function actually calculates a tax. Another case is we can create another function and we can pass in more than one parameter. Now we can also call calculate tip. And the calculate tip actually takes in a bill amount that is in terms of double and also return a data type and call this double. Now let's call this tip percent. So we can just copy here. Let's copy this. Let's paste it here. Instead, let's call the bill amount. Now, what we can do is call a return so that we can return the value. So we can call here our tip percent multiplied by the multiplied by the bill amount. So here we have calculated. Now there are functions that does not return anything. So they take something and again return nothing. So in Kotlin, this way we can just declare a function as normal. Let's give it the name that is called the print the bill, for example. Right? the bill. Now, this takes more than one parameter. So we can call, for example, subtotal. Subtotal, this one is going to be in terms of double. Our tax amount in terms of double. By adding a comma, we can add more values. Let's call here our tip. And this is going to be of type double. Now, in another programming language, you have to specify the return type of a function, even if it doesn't return anything. But for our case, we are going to omit that return type so that we don't have to return anything. We have a unit. So here, we can just call the total bill. So we can just call our subtotal plus the tax amount and plus the tip amount. Then we can just copy the code that is supposed to be inside here. Now, let's keep it inside here. So this is how we actually use functions. Now you can see here, we are not using the functions by this gray colored in Kotlin. You can see calculate tax is never used. Intelj is actually hinting us. Let's create a variable and call this. Let's call here a subtotal. Let's duplicate calculated tip. Now we can call here our subtotal to actually calculate the tip again. Now we have done our two process, calculate the tax, here we have to calculate the tip. We are passing here the bill amount. Now we want to actually print the bill. So we don't have to actually save this inside a variable. So you can see now, whenever we do this, because we have a return type of a double, then we can save this to a value. But we want to print the bill, so we can just call print the bill. Now we have to pass in here the subtotal. Then we can call here a calculated tax. And here, calculated tip. Now the bill is going to actually print here. So you can see the difference now. We have only few lines of code and our main function is actually more readable right now. So you can see we have a function that called calculate tax, calculate tip, and print the bill. And we don't know, the main function doesn't know how the bill is printed until you expand to the print the bill function. And now it's easier. Let's say we have 20 orders. We don't have to duplicate all of this code here by changing this. Right now, we have just to call a calculate tip function. Let's say if the user actually adds another function that to change the subtotal. Now we can actually duplicate only this function here. Let's try to re-execute again. You can see here our restaurant bill. This is the first time. And this one is the second item by using our own function. So another important aspect of functions is having their parameters. So for example, here we have this value. So this value, we know sometimes it can be changing. And by now, it's a fixed value of 0.08. So if we add here, for example, another parameter inside our function, let's call this tax rate. And this one is going to be of type double. Let's remove this. You can see we're going to get an error here. So we have to pass in the value. The value is going to be 0.08. But this tax rate is going to be fixed for many years until, for example, a country changes its tax rate. So for this case, we can use one function of Kotlin, one feature of Kotlin that is called default values. So now we know this tax rate is going to be fixed. So for our case, we're going to add an equal sign to initialize this to 0.08. Now the tax rate will actually use that function directly. Now we can just omit this value because now it's not needed, and Kotlin is not going to lament because it has the value that is initialized inside here by using the default value. Okay, so another cool feature of Kotlin. So you can see this syntax in another programs, so don't worry about this. So for example, we have here only one function. And we can actually just take this and omit this to just directly and call all of these curly braces. Let's delete them. Now, directly here, we can actually add this function by using an equal sign. So you can see we're just changing the double directly to bill amount multiplied by tax rate. Let's remove these curly braces here. Okay, let me keep this to another line so that we can make this more readable. Okay, so our calculate tax here is taking these functions and actually returning this. And our function still remains similar, so you can just use it. So this is just a syntactic sugar, and you can see this. Don't worry, this is just a normal function as how we have declared before. Okay, so now, so far we have seen how to use function and different aspects of Kotlin. But one important aspect in any programming languages is actually collections. So what are collections? Let's first create here a new putting class or file. Let's select file and call this collections. Okay, so now imagine we want to store the score of 5 students in your class. So typically you're going to create here variables. So for example, score 1, then you can give it a value, for example, 85. Now let's duplicate this 5 times. So we can say score 2, maybe 20. So now we actually have 5 variables. This works. But what if we have 100 students? Typing 100 variables is not practical. So this is where arrays comes in. So we have an array, which is a collection, meaning that we can collect variables in one collection that we can store in one variable. So what is an array? So an array is a collection that can store multiple values of the same type in a single variable. So for example, let's create here a variable. Let's call this scores, because this one is going to contain multiple type of scores. And there are different ways of creating arrays. So we can use array of. So for example, we can use here the variables which we have 85, 20. By using a comma, we can separate with values 70, 93, for example, and 50. So all of these variables or all of these data have been compressed into one single variable, which you can try to actually use this. And we have already learned how we can use loops to actually loop through this. So for here, we can try to actually print the variables which we have by using an index. So there is one thing which you have to notice. So I'm going to use I in scores. Let's use this with index. So right now I want to access the index. So there is one thing which let's print first so that you can understand. If you don't know any programming language, then this one is going to actually help you. So inside here, we want to actually access the index. So I can call I.index. Then this index is going to have a corresponding value, which we have saved here. So for our case, let's actually access the I.value. So for this case, we have the index that whenever we want to access that variable, we can use that index to actually get that value. So for now, let's try to execute this and see the output, which is going to be printed here. Okay, let's run here using this. So you can see we have the array. So an array is going to have an index starting from 0. So from 0, this is our first value. That is going to be 85. And then we're going to iterate to another value. So this one is going to be 1 and the value is 20. So as how they have been arranged here. So we have 2 that is going to be 70, 3 that is going to be 93, and 4 is going to be 50. So actually we have a size of values. So we have 5 values inside this array, but the index is going to start from 0. So you have to keep in mind if you don't know about collections. Now, an array by default is actually mutable. So in Kotlin, we have a concept of mutability and immutability. But with arrays, by default, they are mutable. So meaning that we can actually access a value and actually reassign it and change the value which we have. So for example, we can check the scores to access a certain score. So we want to access, for example, this second value here. But remember that the index starts from 0. So to access this one, we can use 1. So we know that maybe we made a typing error instead of 20. So the value should be, for example, 50. So inside here, you can see we can reassign this by accessing the score in number 1 position. So we want to change this to 50. So when, for example, you try to make Println and we want to print that values, so we can just call scores and call 1. Right now, we are going to get only these 1 values because we have used the index to actually calculate that. Now, when we try to re-execute again, you can see now we are just getting this and we have made the changes to 50. So this is how you can actually make changes in an array. An array is a collection in Kotlin that has fixed size. So you can take an example like an egg tray. So an egg tray can take a fixed amount of values. So in this case, whenever we create an array of 5 items, we cannot increase it to maybe 6 eggs or 12 eggs. So for this case, this is going to be the fixed values. And its size is actually going to be determined when you create it and can never be changed. So it's fixed and it's mutable in elements by default. So we have other items that we can use to store collections. And this one are native in Kotlin, so we're going to speak next. Okay, so in the previous lesson, we actually saw how we can use arrays. So in Kotlin, we have other list of collections that we can try to use. So the first one, this one is going to be list. So we have a list collection. A list is actually an ordered collection of items. So like a list on a piece of paper. This is the most common type of collection that you're going to encounter. They are ordered in items and they are stored in order as how you add them. So the first item you add is going to be at the index 0, and then the second is going to be at 1, and so on. And this actually allows duplicates. You can have the same item in the list more than once. So here, let's declare a list, for example. So we can have a shopping list. We can use a list of. Now, inside here, we can have, for example, we want to shop for apples, bread, and actually we can have duplicate values and add apples. No problem in this. You can try to actually Println and actually use the shopping list. We can easily access the shopping list by using an index. And by default here we have mutable and immutable values. So a list we cannot actually add. So for example, let's try to actually add here. And we want to check the first item. So inside here, we can just call our shopping list and access this by using a get function, or we can easily, so we want to get, for example, 0. And you can see here, Kotlin is highlighting us. There is a shorter syntax. We can replace this call with indexing operator. So this is an operator that we can use to actually access the value, or you can use the get value if you want. So here we actually access the first item inside the list, which is going to be apples. Now let's try to execute here. And when you execute, you can see we have these brackets or angle brackets. This denotes that this is an array. And we have apples, milk, bread, and apples. And the first item is going to be apples. So this is actually a list. It's immutable by default. So if we try to add or change any value, so for example, if we access maybe the second value and we want to change as how we did with arrays, no set operator method providing array access. So we cannot actually change this type. So for this case, even if we try to add another item, we don't have an operator to actually add inside here. So this is going to be mutable by default. So let's create here Println. So here we can initialize this by using a mutable list of. So by default, Kotlin want us to actually specifically say, hey, we want this to be mutable, and we can change this. So for example, we can say wash car. The second variable may be do roundly. Now, if we want to, for example, let's try to Println here, we can say today tasks. And here we can call my task. So we can print the today task. Maybe at the later time, we forgot that we have not bought our groceries. So what we can do is call my task and actually add a certain task. So for here, we can say buy. So inside here, we can try to Println. Now let's try to execute a collection here. So you can see we have printed today task. We have a wash car and do laundry. But now we have updated here our task. You can see we have another item that is buy groceries. So this is how we create a mutable and immutable list collection inside here. And also we can access these variables similarly as how if we want to access, for example, the second value. So we can say second task. So here we can easily use, so here we have to open up these two curly braces and open up here. We want to select the first item, or mean the second item inside our list that by index is going to be represented by 1. So this is how we create mutable and immutable list in Kotlin. Now we have seen a list. So a list has some other issues. For example, this one allows us to have a duplicate values. So we have apples and here also apples. But there are some values which we don't want to allow duplicates by default. So we can use a different data type that is going to help us to hold the data in a unique sense. And this in Kotlin is actually offered in a set. So a set is a collection of unique items. It's like a list, but it's guaranteed not to have any duplicates by default. So the key characteristics with the set is no duplicate, and generally they are unordered. And the primary use is actually to ensure that a collection only contains unique items. So for example, if we want to track unique website visitors, or a student can be enrolled in different courses inside your courses. So you want to know how many students do you have inside your all courses. So for this case, you can use a set to keep track of students or visitors inside here. So for example, let's create visitors today. Now we can create a mutable or immutable set. So for example, let's go with a mutable. Here we can provide a data type. So we're going to speak about these angle brackets. But for now, this is a mutable set of strings we want to actually add. So for example, today, again, our visitor is going to visit here. We can add, for example, so let's duplicate this. Somebody else, for example, Bob. Now Said visited again. Let's duplicate this. Now at a later time, Bob visited again. Now you can see we have added visitors. Now let's try to actually Println and say visitors. Let's execute this. So you can see here we have added 4 items, 1, 2, 3, 4. But here we have only Alice, Bob, and Said. And you can see these are just 3 items which we have. This one is a duplicate. So a set will by default guarantee you have only unique items. Okay, so we have seen a set, and a set and list have their own key characteristics. Now, another collection in Kotlin is actually a map. It's like a dictionary, a collection of key value pairs. So we are saying it's like a dictionary or a phone book because you can use a unique key like a word to look up for its corresponding values. So if you have one word, for example, in a dictionary, and you want to get the meaning of that. So for this case, we can use that. What are the key characteristics of maps? So keys are usually unique. You cannot have duplicate keys in a map to actually point to different items. And you can access them by using a key. Let's declare here, for example, a map. So we can say user profile, and we can use map of. Now inside here, we can say, hey, we have the first key that is going to be name, and we can use to map this to a value. So the name is actually, for example, Alex. We can have another key that is H, and we can use 2 to map this. Okay, here let's add a comma. And here we can use 2 to map it to a value. So we have this, the name, age, and actually country. So here, how can we access the value? So we can println here. Let's call this user profile. So how can we access the values? So to access the value, for example, the username, we can use the key that we have specified. So let's say we want to get the username. So here we can call the user profile and access by using the key. So what is the key? Here the key is actually name. Let's try to execute and see. So you can see we have here the user profile, which we have printed, all of this. And this one is using the closing brackets like an object in JSON. And here we have the name that we have accessed because we have used the key value pair here. So let's say we have this one. So we can try to println here. So we can say initial. And we can pass in the student grades. Now we want to add other values. So we can call here student grades and we can provide another key value. So this value does not exist. So for example, you can say science. And we want to initialize this to a certain value that is going to be 95. Now we can println here. Let's call this updated grades. So after we insert grades, then we can println again. So the initial grades is going to be math and history. But now after we inserted the grades, you can see we have math, history, and science. So this is how we actually insert a new value inside our program. Now, let's say we want to actually update a score. So we made a mistake for mathematics. So we can call here our student's grade and access the value. So for example, we had math. So we can access the math value and change this back to 90. So this way we are updating an existing value because this key is already existed here. And you can see math is 85. Now we are going to update this to 90. And remember, maps does not allow to have two keys to point to different values. So for this case, it's going to omit the previous value and go with this one here. So we can try to println here. Now let's access the student grades. Let's open up here and call student grades. Let's access the math property. Now let's re-execute again. You can see the math score is going to be 90 after we do the update here. Now another case is how can you loop through this? So we can have this list of collections. So inside here we can actually destructure this, get the subject and grades. So let's call this subject. And here we can use an in and call students grades. Now we have two values that we can actually speak to. Now inside here, we can println. So let's say, and here we can use the actual grade that we have actually specified. Let's re-execute again. Okay, so you can see we have here our subjects. Grade in math is actually 90, and grade in history is 92, in science. So this way we can access the key and also the value and use them inside our program. So these are the common collections which you are going to encounter in your day-to-day programming life. Okay, so in the previous lesson, we have seen about sets. So in this lesson, we're going to focus on another collection that is called a map. So a map is a collection of key value pairs. So it's like a dictionary or a phone book. You use a unique key like a 1 to look up for its corresponding values. So a map has a key characteristics of key value pairs. So each entry consists of a unique key and a value of that corresponding key. So keys are unique. You cannot have duplicate keys in a map. If you add a new value with an existing key, it will actually overwrite the old values. And how can we access the value? Basically, we're going to retrieve the value by using its key, not a numerical index as how we did previously using the sets. And actually, so for this case, let's look at an example of declaring immutable maps. So for example, let's declare here a user profile. And inside here, we're going to declare a name. For example, let's use string. This is going to be a key for that particular item. Now, to map this to a certain type, we're going to use to. And now here we can say, for example, it's called Alex. Now we can add another item like age, for example, and we can use to map this to another item. So let's map this to 28, for example, because this is going to be an int, and a country. And here we can pass in, for example. So this is how you actually declare a map. And this is going to be immutable, meaning that we cannot add other values. So let's just write here println function, and we can say user profile. And now we can println here. Let's try to actually run this. Okay, so you can see here the user profile, and here we're using curly braces. So this means that this is like an object if you know JSON. So this is going to be an object that contains some items that we have. So for example, name, age, and country. So everything is actually provided here. So how can we actually access the values? So for example, we want to get the username from that profile. So let's call this username. So let's call here user profile. So we can easily use the key. And the key for the username is actually name. You can see here we have declared. So you can just access here by calling name. This way we can get that particular item. So you can see we have here the username is Alex. So this is how you actually access a value. So we have seen this is going to be immutable. So we cannot add or change the data which we have created here. So let's say that you want to create mutable ones. So we can declare here, for example, let's create a mutable map as how we did before. And here now we can declare key. So for example, we can say math, and we can map this to the score that is going to have. So for example, 85. So these are the student grades. So let's create here println, and let's say initial. And we can call here our student grades. So these are the initial grades before. Now, how can we add a new value? So we can just call here students, and we can try to access that grade. For example, we want science. So this key is not actually inside here. So map is going to look for this key and say, hey, I don't have this key. So meaning that I have to initialize this. Let's say the student gets 95. And you can see the difference. So this is actually how we can add a new key value pairs. Now, let's say we want to update an existing. So for example, the student has taken, again, an exam of mathematics. So we can call students. And here we can access by using the same key. So make sure that you have the same correct way of typing here. So no mismatching of case, not using here, for example, math. It's going to add this as a new key. So for this case, when we call math here, for example, we can say the student got 90 right now after retaking this examination. So we can create another println function. Let's print here our student grades and see the difference. Let's try to re-execute here and see. Okay, now you can see our initial grades is these two. Now after adding science, you can see we have 3 items. And here after we retake, meaning that we are making changes, you can see now it's 90 instead of 85. Okay, so let's say we want to loop through a map. So we can easily do this by using a for loop. So inside here, we're going to use a simple syntax is that we're going to destructure this because we have a key and value. So for here, we can use, for example, the key is going to be the subject and the actual value is going to be grade. Now we can use in students grades. Now we have access to the key and also the value, so we can reuse them in our program. So for example, we can print string. So we can say grade in it has looked through all the three items. So we have here math, which is actually the key, history, science, and these are the scores which we have specified. Okay, guys, so we have learned a lot throughout the previous section. So these are the basics of Kotlin. So until now here, you are now ready to start to learn other advanced topics. So for now here, want to create a new package, you can press Command N or Control N in order to select package. And here let's call basics. Now I'm going to refactor all of these, copy and shift them so we can drag and drop inside basics here. Then under IntelliJ is going to help us to refactor this. Let's refactor this code and keep it inside basics. So I want to restructure here our project so that we can easily read this. Okay, now let's create another package. And here we can just call this. And inside here, I'm going to create another package. So if you don't know, you can just press right click or control click here and create a new and select package. And here, let's select OOP. So we're going to learn about object-oriented programming in the next lesson. So let's create here a new Kotlin class or file. And here we're going to select file. Let's write here. Let's create here a main function. Okay, so let's imagine that you're building a program to manage students in a particular school. So at first you might write something like this. So there is nothing wrong about this. Let's assume that you have 10 students. So what you'll have to do is copy all of these variables and duplicate them 10 times. Now let's assume you have just to change all of this and keep track of the variable names. You can see here now all of these variables are repeating themselves. So you can see conflicting declaration. So we cannot actually manage this. It is going to be tiresome for us. Maybe you might be thinking we can use a collection like a map. So that is the valid approach, but also that is not manageable. So OPP is going to solve this, or object-oriented programming is going to solve this by grouping related data and behavior together. So for this case, this is a new paradigm in programming. So it was most popular in Java, and Kotlin actually adopts this by grouping related data and behaviors together. So instead of scattering all of these variables, we create something like a student object that knows its own age, name, and grade. So in object-oriented programming, we have a concept of classes and objects. So we have classes and objects in. So you can think of classes blueprint or the plan that we have created. So this is a blueprint or plan. You can say like that. So an object is, we're going to use the classes to actually construct objects. So let's define here a simple class. For example, let's come below here and we can define a class by using class and call this student. Now with this, we can open up to create a constructor. So this way we can now define what we want our student to actually contain. So for a case, we want to have the name. And here we can specify the name to be of type string, for example. The next variable is age. And here we can specify this to have the age. Sorry, the age should be of type int and also the grade. The Then we can use this blueprint to actually create actual objects of students. So below here, we can try to construct this by creating a variable and call, for example, student1 and call our student class and execute. Now we have to actually pass in the name, age, and grade. So you can see even Intelj hints us we have to pass this. So our student name is, for example, Amina. The age is 20 and the grade is going to be A. So you can see we have grouped all the data inside one object. Now here we can duplicate this, for example, to create the second student. Let's say the student is called Alex, age 19, grade to be B. So as simple as this, we have created two students, not scattering the variables in different places. So we have said that the class contains properties and behaviors. So here we have properties. These are called the properties or the variables that should be provided. Now we can provide the behavior and give this class to actually perform other actions. So for example, we can create here a function that is going to display information. And this function is going to do one thing, print the information. So we can say, for example, name. So we cannot access these variables here if we declare like this. Let's create them as variable. Adding a val, we are making these variables accessible inside our body object. Now select the option, Command L to actually reformat. So for this case, we have accessed the name. The next case is age. Now for this case, we can call, for example, student1 dot display information. And let's call also student2 display information. So we are keeping all related data inside one object. Like this, we can easily access this. Let's use this button here and click run. Now you can see we are printing this by using this function here. So this is actually a class. So let's say the student goes to the next year. Now their age changes. How can we change this? And we have actually instantiated the student. So let's say student1, and we want to change the name. We want to change the age. Let's say they are 21. So you can see we are getting here an error. So we cannot reassign this because we used a variable. So for this case, we can just change this by using a var. And now you can see the age is actually changing, and even IntelliJ actually allows us to make the changes. Okay, so in the previous lesson, we have learned about objects and classes, and we said that classes are like a blueprint or a plan, and objects are real things that we create from that plan. So there are different ways of actually defining a class. So here, let's just create a new file. Let's call this constructors and define our main function. Okay, now let's create here a class and let's call this students and use sc for constructors because we have already defined inside here a student. So for a case, let's just call student C so that we cannot have conflicting values. So when we create an object from a class, Kotlin needs a way to initialize or set up that object with the data that we are going to supply. So that's what constructor does. It's like a special function that runs automatically when an object is actually created. So for example, we have created here a class. Now we can specify the constructor by using these two opening brackets here and define, for example, the name that is going to be of type string and age that is of type int. So this way we have defined our object and this one are necessary. So now this we have provided here is called the primary constructor. So we can construct here a student. So when we call student C, basically here we're providing the class with the data which is required. So for example, we can provide the name. So now the constructor is going to run and set the name to Amina and age to 20. So right now we have used this primary constructor. So you can have a secondary constructor that needs different values, for example. So for example, this one primary constructor is used to construct a new student. Now, what if we want to construct an existing student? So we can create another constructor. Let's call this like a constructor here. So you can see we can provide other arguments to make this constructor. So for example, we can call the name to be of type string. Now we can call here this in order to access the name and the age. So we can call name. So here we're using this keyword to actually have access to these variables here. So now we have access to the name and age by using the primary constructor to construct that object. Now we can create other variables, for example, like grade. So inside here, let's, for example, declare a variable and call grade. And this one is going to be of type string, for example. And by default, we can just give it an empty string to initialize this. So here, by using the secondary constructor, we can actually use this to grade. So we're using this again to have access to this one here. And then we can assign to the grade. So in this case, we can actually create a new student. So like, for example, let's come here, create a student C. We can provide the name to be John, age, for example, 19, and a grade to be A. So here we have used a secondary constructor. So the primary constructor is going to handle all the name and age, and the secondary constructor is going to add grades and other things. Sometimes before we initialize an object, we want first to perform some validations or anything else. So we want to run some code before or right after the object is actually created, like checking if the data is going to be valid. So here in Kotlin, we have something that is called an init block. So init block in Kotlin, we can use it to actually perform code after only the constructor here is going to be called. So we can call init, and inside here, let's write a Println function and say, and here we can, for example, access the name. So we know, okay, this student is already created. Now we can perform a simple check. For example, we can say age less than 0. We can tell the user, hey, this is going to be an invalid age. So let's write like a warning. Or we can throw an exception inside here to tell, hey, you cannot construct this. So for this case, let's just come here. Let's construct, for example, student C. That his name is going to be, for example, Said. Age is going to be, for example, -1. Now let's use this pattern here to actually run our code. Okay, so you can see this student is created, and now we have executed here the warnings. We have invalid age in the student because we used -1. So init block is going to be executing after we only construct here our object by using this constructor or using this constructor here, and the init block is going to be executed. So let's say here our student class actually need also to store about scores of that particular student or subjects that student actually takes. Should we create another constructor? So this one is going to be unmanageable to create many more constructors. There is another way which is going to be easier for us to manage. That is called default parameter values in a class. So you can use default values in functions, in classes, and different ways where you're going to actually specify variables. So for example, let's define here a variable that is called the score, and this one is going to be of type int. Now this variable is actually required. So you can see these students here, we are getting error because we have not specified the values for score. But let's say this student here is actually a new student, so they don't have any type of score. So for here, we can easily just create sorry, let's keep it here 0. Okay, so we can easily create a score value by using default values. So now the compiler here knows that these values is optional, but if it is required, then we are going to supply 0 by the default values. Okay, guys, so in this lesson, we want to learn about encapsulation in Kotlin. So encapsulation means hiding the details of how data is actually stored in a class. So for this case, let's create here a new Kotlin class or file. Okay, for now, let's just create here a class and let's call this bank account. And here we can declare a variable and let's call this balance. And this balance is going to be of type double. Okay, inside here, we're going to give this a default value of 0.0. So now we can create here our bank account. For example, let's instantiate this by calling bank account, because there is no any parameter that is required. So we can call here, for example, account.balance. And actually, let's assign this to negative 100. Okay, so we are allowed direct access to the balance, and someone set it to a negative number, which is going to break, for example, our logic. So we cannot set the account balance to negative. So that's why we need encapsulation. So to iterate, encapsulations means hiding the details of how the data is actually stored or modified inside a class, and only exposing what is actually necessary for the user to actually know. So we're not allowing direct access to actually change the values because it's going to break our logic. But if we have other methods that actually require to use this, so this one can crash our application. So now let's just create here another class and perform a little bit of encapsulation for a bank account. So let's create here a class, call this bank account. Let's use E for encapsulation. Okay, so inside here, we're going to create a primary constructor. Let's create a private variable. Now we are making this balance actually private. So a private is a scope modifier that is going to restrict this variable to be only accessible within the class. So we can call here balance. Okay, so now we have made our balance actually private. So we cannot actually change this balance inside our class. So we don't have direct access like this to actually modify the balance. So how can we do this? So we have to define methods that are going to actually change this. So this one is going to be predictable. So let's call this, for example, deposit. And this one is going to be of type double. So here we can perform a simple check like, is the amount going to be greater than 0? So accidentally, the programmer can change this and actually create something that is going to break our logic. So we can use the assignment operator here to increment this amount. So we can take the balance plus the amount. Now we can write here Println function, for example. And else we can just make a Println. And we can let the user of this class to actually understand that they used a different one. And we can create, for example, a function that is called withdraw. So we can call the balance here, and we can use this assignment operator to actually decrease. So we're taking the amount and decrease that balance. So here we can call our Println function. And we can expose, for example, another method that is going to actually check balance. So here we have this bank account to actually construct here. So for example, let's now create an account too. You can use this. Now we have to provide here the parameter for that actual balance. So for example, the student has started with $500. Now let's call here our account 2 and actually deposit $100, for example. Now account 2 again has withdraw 200. Now we can check the balance. Now you can see we're checking here the balance. Now let's try, for example, we deposit here negative 100, for example. Okay, now let's execute your code and see. So you can see here we have deposited and our new balance is 600. Now withdraw 200, the balance is going to be 400. We have checked our balance after some times that we have 400. Now we try to deposit non-valid values. So we actually tell the user, hey, this is invalid deposit amount. And if we are in a real program here, we're going to throw an exception. Okay, so in Kotlin, we can use different modifiers to actually change our variables encapsulation. So for example, here we used a private modifier to actually restrict this to this particular class. But sometimes we want to allow the user to actually change this rather than using a private modifier. Because you can see here, when we want to try and change this variable here, we cannot change it outside of this class. So for example, let's say we have a variable that is called account name. So this one is going to be, for example, of type string. And by default, this is initialized by an empty string. So now we can call here to use the set value. So with this set here, we are actually restricting this. We can even call this as a private set so that it can only be set inside here. So this is going to be actually read outside. So this one is similar to how by using private val balance, but we're just restricting here the private modifier. So now we want to only perform a check if the certain condition is going to actually be there. So we can write if value dot is not blank. So if the value is not actually blank, we can call our field. So the field is actually this item here. So this variable, which is going to actually hold this value. Then we can give it the value that is the value which we are going to actually provide. And else we're going to make here a println function. So this way we have our account name. So let's come here, for example, to account 2 and call account name, and we can assign this to an empty string. Let's try to execute here. You can see directly we have assigned this to an empty string, and here we are getting invalid name. Name cannot be empty because inside here we have used this custom setter to actually perform this. Let's try to actually set this to a certain name. Let's say now we can try to print lane. So you can see here the account owner is going to be Said. So this is actually how we restrict set values by using a custom setter in Kotlin. Okay, so in the previous example, we have seen how we can use a custom setter to actually perform setting of values. Let's say we want to create a custom getter in a certain variable. So let's declare here a variable and call this. So this one is going to be of type string. So this value is going to return as a formatted balance. So inside here, we can actually perform a custom getter. So let's give this getter. And inside here, for example, let's use a $sign, and actually we can assign here string.format. Okay, so we want to have only 2 decimal places, so we can use this simple format. Let's use $sign dot 2f to actually contain 2 values. Now we can pass in here our balance. So you can see we're using this custom getter to actually return this value. So whenever we call formatted balance, then we're going to perform this action here. So instead of creating a separate function that is called formatted balance, we can just use a variable here. And this is a Kotlin way of doing things. So inside here, for example, we can call formatted balance. Let's try to execute. So you can see this is the formatted balance which we're going to get here. This is how we are actually implementing encapsulation in our classes. So we are limiting how the data is actually read and how it's actually set by using different modifiers. Hello and welcome to this lesson. So in this lesson, we're going to speak about inheritance. Yes, correct, inheritance. So as how you have inherited some traits from your mother or father, then in programming also we have this concept of inheritance. So we have a relationship between classes so that we can group related data and also avoid duplication of code. So let's see how we can actually achieve this using Kotlin. Okay, now let's create here a new Kotlin class or file. Let's select file and call this inheritance. So let's speak about inheritance in programming. So inheritance allows one class to actually use the properties and function of another class, just like a child inheriting traits from a parent. So it helps avoid repeating the same code in multiple places. So for example, imagine you're creating a school system. So teachers and students both have name and age, but you don't want to copy paste all those variables in both classes. So you create a base class called, for example, person, and then make both teacher and student inherit from it. Okay, now let's create here a simple class in Kotlin. Let's call this person. Now this person has a name. So we have created here a class person, and you can see this is just as normal. So in Kotlin by default, not like Java, classes are final by default, meaning that they cannot be inherited from another class unless you mark them as open. So here, for example, let's try to create a class that is called the student. Whenever we try to actually inherit by using this 2 colon after the class, then we can pass in the class that we want to inherit here. So whenever we do this, you can see directly now this type is final, so it cannot be extended. So we cannot actually extend. What we can try to do here is write open. Now, whenever we write open here, you can see right now that this type has a constructor. So we have to use the constructor to actually provide this. So by providing the constructor here, you can see everything is looking perfectly. So here we have to pass in the name and age. So inside here, our student, we can create the name that is of type string, age of type int, so that we can pass to this constructor, and we can give it other variables that we want this specific student to have. So for example, let's create here a variable and let's call this grade. And this is going to be of type string. Now, in order to remove this error from the person, then we can pass in here the name and age. So now everything here is looking perfectly. So we can open up here and add other methods. So right now the student class has actually inherited from the person class. But from our person class, we don't have any type of actually any method. So in order to actually inherit something from this class, let's create here a method. And this method, like let's say introduce, okay, so a simple method like this, actually the student class has actually, so here we have, let's call this student I so that we can just inherit this. So by using this I for inheritance, so we have to change this. We had a read declaration. So now we can let's create here our main function and try to use this student class. Like let's create a variable called the student. So let's use the student I and make the constructor. So the name is Amina, age 20, and here the value to be A. Okay, so we can call here our student.introduce, for example. And now it's going to introduce which basically this class has inherited. So this is inherited from person actually. And here this student can have another method like, for example, let's say student is going to start. So as now, you can see we are using the name here, and this name is going to be directly inherited from the person. So if you press the cursor here and press Command B or Control B in PC, you can see it's going to take us to the person class, because here we did not use the variable var, for example, because you can see here by grade, we are using this. You can see, let's say, we can say here with grade and use the grade variable. So this variable here is actually not from this. So that's why here we have declared by using the val. So if you will remove val, you can see we cannot access this inside this scope. So we have to say here val so that we can access this. But inside here, we did not use val, but we have accessed the name. And basically, we are not using the student name, but we're using this from the inherited variable that is coming from the person. And whenever we are inheriting here, so we passed the name and the age here. So these are going to be similar to us how we are going to construct this. So this is the simple inheritance in Kotlin. So sometimes we want to actually inherit a method like here how we did. So you can see here we used this method introduce. But within that method, we want to actually perform other actions like change it at the user. So we want to override that particular method and actually provide our own implementation. So what we can do, let's come here and actually create another function. Let's call this, for example, and here we can create and say hello. So as simple as this. So this method is not used, but now we want to actually override that method. So we can use an override keyword. So when we write override, but right now we don't see that method of greeting. So by default, also functions are actually final in Kotlin. So this we cannot change, but until we actually add the open keyword as how we did here. So when we say open right now, so let's come here, override, and create greeting. So you can see whenever we write greeting in this student class, we have an override and function and Android Studio. So let's press tab. Now, inside this greeting, we can actually provide our own greeting. Let's write here, Println. So we can say, you can see, because the greeting here, we want to actually use a variable that is actually available inside the student class and not directly from the person. So whenever we want to do this, then we have to use the override and actually override that particular method inside here. So let's try to actually execute this. Okay, so now when we execute this, you can see the first case, which we printed here, is actually the greeting. And now you can see is Amina is studying hard with grade A. So let's use first the student and use the greeting method. Now let's execute here. Okay, so you can see this is the method which we actually overridden from the greeting. So when you press Ctrl B, you can see this directly take us to the overridden method. But let's go to our study function. Let's press Command B or Ctrl B. You can see here, sorry, I want to use the introduce because we have used this from student. Let's press Command B. And this one directly take us to the person. So have you seen the difference? When you press Command B with the greeting, this one is going to take you to the overridden method that is going to be available in the student class. So now sometimes you want to actually use the function that the parent has and actually add other code. So here you can see actually whenever we overridden the greeting function, we actually provided our custom code. So the code that is actually provided, let's press Command B to take us to, sorry, let's press Command B. This one is taking us here. So let's come here inside our person class. So inside here, we had a println function that is going to print, hello, I am name. But right now here, it's actually only printing this function here only. But let's say we actually want that code from the parent to execute first, but also we have other functions or other code which we want to actually also execute. So how can we achieve this? And here basically we can use the super keyword. So the super is going to call the parent class. So let's use a super, for example, here and call .greeting. We are calling this function. So before this, so if we call this after this, then this one is going to be executed first. And after that, then this function is going to be executed. So when you remove this, then the function from the parent class is never executed. And if you include this, then this is going to be executed. So here we had this function. Let's try to run again and see. So you can see we have to println function. So you can see, hello, I am Amina, and then there are other printing function, hello, I'm Amina, and I have grade A. So these are two variations, but we only called greeting once. So this is the use of the super keyword. So in the previous section, we learned about inheritance. So inheritance is important in object-oriented programming. But in this lesson, we're going to learn about polymorphism, one of the most powerful idea in object-oriented programming. So maybe wondering what is polymorphism. So the word polymorphism comes from the Greek word that means poly, many, and morphs means forms. So polymorphism means many forms. So this concept allows you in programming to actually have different classes to be treated as one common type, but each behave in its own way. So if I'm confusing you, let me give you a simple example. Let's create here a new Kotlin class of file. Let's select Kotlin file. And here, let's call this. Okay, so inside here, I'm going to create an open class. And let's create here an open function. And I'm going to create two classes that is called the student. Okay, so we have first to inherit from the person class. And here, let's pass in the name. Okay, so inside here, let's remove the variable because we'll have declaration of name. So here, let's call this person P to actually use the person, for P stands for polymorphism. Okay, so here we can override the introduce function. And here we are not going to use our own. Let's call Println. Okay, let's create another class. Let's call this teacher. And also the teacher has the subject that is going to teach. And this one is going to be of type string. Inherits from the person P. And here, let's pass in the name. Okay, so here we can override also the introduce method. Let's write println. So here we have three different classes. So let's use a student P. Okay, so we said polymorphism means many forms. So let's create here a main function and actually demonstrate this to you. So let's create a variable that is called persons. So inside here, we're going to have a list of persons. And here we can construct a simple list. Now, the type here is actually person, but we have teacher and also we have student. But all of these, they override from the same parent. So for this case, this means they are the same type. So here comes the power of polymorphism. So we can create, for example, the student P. Let's call the name to be, for example, the person is not the person, it's person P, so that we can go with polymorphism. Now the grade is 45. We used as a string. So let's change this to be. Then here we can create a teacher. But here, let's say Said, and teaches subject. Let's say Kotlin, teaches Kotlin Programming. So you can see we have different, let's create here a person. And the person is called, for example, Hassan. Now let's see the power of polymorphism. Now we can actually create a for loop. We can use the person to actually get a single person in this person's function. So you can see this variable, person variable. Now we can call here the person dot introduce. Now here the introduce, the person will actually call the function that corresponds to that particular class. So let's try to execute this. Let's call here and run this function. So you can see this introduce for the first class was our student. You can see with the grade. Then now this is going to be the teacher. I teach Kotlin programming. And here a person, I am person. So simple as that. Okay, so actually what's happening here? So we have a common base class that is called a person. Both a student and teacher actually inherit from it and override the introduce method. In the loop, we treat every object as a person. But when we call the introduce, the version that matches the actual type, for example, the student or the teacher, is actually going to run. So that is called runtime polymorphism. The decision of which function to run happens while the program is actually running. And why is this going to be useful? We can write one function that works for many related types. And actually, it's easy to extend and add a principal, for example, janitor or a parent class later without touching this particular loop here. So for example, we can have a janitor and actually introduce, and this is going to be different. But we don't have to touch any type of code inside here or inside the for loop. Basically, we're just going to introduce here another type, and the loop is not going to be touched. So we have seen how we can use inheritance and polymorphism in our code. But another important aspect in programming or Kotlin is actually abstraction. So what is abstractions? So this means showing only what's necessary and hiding complex details under the hood. So the user of that particular class doesn't know how something is done. So for example, think of driving a car. You just use the steering wheel and pedals. You don't worry about the engine's inner working when I steer to the left. So in Kotlin, abstraction let us define a structure without focusing on the details right away. So we have seen here, for example, inside our, let's go to our polymorphism class. I want just to copy these three classes. Let's press Ctrl C. Okay, now let's create a new Kotlin class. Let's call this abstraction. And I'm going to paste this code here. And let's change this person P to go to use A for abstraction. Similarly here, let's use A for abstraction and teacher A for abstractions. Okay, so right now here we focused inside this introduce method with the code that we want it to be. But for example, sometimes we don't want to actually show this. So we want actually the student who is going to override to provide it. So for this case, let's just change this and remove the code here primarily that is going to be provided. But right now you can see function introduced without a body must be abstract. So we can just use the abstract keyword. Let's remove the open keyword. And now we are supposed also to make this class abstract. And then we can change. So you can see right now here we don't provide any details about the introduce function, but these methods, they are going to actually know how to use it. And because we don't have a class that is called a person. So for example, a person must be, for example, a parent in a school environment like that, or is going to be a student, a teacher, a janitor, or having a certain title. So we don't have just a person that is sitting around in a school. So by making a person abstract, this means that we cannot construct a person directly. So let's create here a main function, for example. Let's come here. Let's create a main function. Let's say we want to create a variable that is called person. let's try to introduce the person by using the A for abstract. You can see right now we cannot construct this. You can see classifier class A does not have any companion object. So meaning that we cannot construct because it doesn't have the constructor. So, and here we have just to, no need, we can leave it as that way. Even if we provide here a constructor, you can see still we are getting here an error. Let's pass in here the name, for example. Let's give it an empty string, but still we are getting an error because Kotlin is going to limit us. We cannot create this class. We have seen that we cannot create a person because the person is actually abstract. Now, here, for example, student. So when we're using polymorphism here, for example, we used the open class, and here we used open. So for this case, for example, we can actually remove the introduce function. Nothing is wrong here. So everything is working perfectly. But let's go inside here abstraction. Now let's try, for example, to remove the introduce. Okay, so you can see here we're inheriting still from person A, so nothing changes here. So let's use person A. Now you can see student A here is actually getting a problem. Okay, similarly here, let's use A for abstraction. So now we are actually inheriting directly from this one here. So you can see this one class student A is not an abstract, it does not implement abstract-based class member. So for this case, we have to implement this method. So inside here, we can press command enter or option enter in MacBooks or alt enter in Kotlin. So inside here, let's hover around directly and click implement member. You can see we have the introduce method, and now we have to implement this method because right now it's actually needed. Let's just copy this from the student. So this means, for example, here, let's create another function. Okay, so we are creating this function, for example, greeting, and here Println, and say, so right now, even this teacher or student, they does not actually implement this method, but nothing is wrong here. So here, basically, what's actually happening, the class person is actually abstract, and we cannot actually create a person object directly. Then the introduce function is actually abstract. So for example, here the introduce function is abstract, and this means that each subclass must actually implement it. So if we omit it, then we're going to get a compile time error. And the greeting function which we have created is actually concrete and shared by all subclasses and no need to actually implement. So this case ensures all person types have a common structure while leaving each subclasses to fill its own detail by using structure. So why is this useful? So this is useful in order to enforce consistency. So every subclass must define certain behaviors on its own context. And this one is going to hide unnecessary details. The previous lesson, we have seen how we can achieve abstraction using an abstract class. But there is another concept in object-oriented programming that is called the interfaces. So an interface defines a contract, so a set of method and properties a class must actually provide. So unlike abstract classes, interfaces don't store data directly. So they focus on what should be done, not how things should be done. So simply think of an interface as, for example, a bank policy manual. So every account must be able to deposit, withdraw, and show balances, for example. So each account type then follows this manual on its own way because they are going to be different in deposit, for example, or withdraw, or showing the balance. So let's create here an example. Let's create here Kotlin class or file. Let's select file. Let's call this interfaces. Now in Kotlin, we can create an interface by using the interface command. So the interface here, let's call, for example, this interface account operations. So inside here, we can define several methods that we want all account operations to have. So for example, an account should be deposit. And here we have, for example, let's define an amount that is going to be of type double. So we can withdraw, also amount to be double, and have a method that is going to show balance. So this method does not take parameter or return any parameter. Right now we have just defined the contract. So each class that is going to inherit from the interface must provide the concrete implementation of that particular. So let's create here, for example, a saving account. Let's create a class. Let's call this savings. Here we can create a private variable. Let's call this, for example, balance. Now we can inherit from the account operation. So you can see even Kotlin here gives us a different icon. Now here we have implemented. And now you can see we are getting an error. So it's not an abstract and does not implement abstract members. So for this case, we have to actually implement these members. So let's open up our body. Let's press Option and return. Or let's keep our cursor here, Option return, and call implement member. Let's select all the members. You can see all the members here we have. For example, here, whenever we deposit, we can use the assignment operator here and use the amount. And add a Println function, for example. Okay, so similarly here, whenever we withdraw, so we can check if, for example, then we can change the balance again by using the assignment of operator. Let's use amount. So as simple as this, or else we can just picture Println. Now here, for show balance, we can actually create a Println function. And here we can just call the balance. As simple as this. Now let's create another class that is going to be, for example, the current account. So we can create here a class. Let's call this the balance to be of type double. Now we can create another variable. Here we can use a default value. We can say, for example, $500 this guy as an option, having an overdraft limit for $500, for example. Now we can call here account operation to actually implement. Now we are getting here an error. So we can try to implement the members and click again. So as how we did here, now we have all these operations. So let's just copy this because it's going to be similar. Let's just copy, for example, and paste it here. Let's change this to var. So now we are having here a current amount. For example, whenever we are depositing, so we are saying deposited to current account. Now, whenever we withdraw here, this one is going to be a different one because we have the balance and the overdraft limit. So we can say overdraft limit. So withdraw from current account and the remaining balance. And here insufficient balance. And here we can call current account balance. So here we can say insufficient balance, or we can say overdraft limit exceeded. So as simple as this, let's create here our main function. We can create here a savings account. So let's use 1000.0. Now you can see we can use also accounts operations as a data type here. So you can see we have savings and the data type is account operation. And now we're using this, but no problem because we have inherited from the accounts operation. Now, similarly, let's duplicate this. Instead, we can use just current account. And here, let's call current account. Let's say our deposit is $500. Now we can use here our savings account. For example, we can deposit $200. We can use a withdraw. Let's withdraw $500. Now we can use the current account, for example. We can deposit also $100. Let's call our account and withdraw 900. And here we can say, for example, account balances and show balance. So as simple as this, we have created our program. Let's try to execute here and see. Okay, so you can see here we have deposited 200 to savings, and our new balance is this one. We can withdraw, and now we deposit, for example, to the current account, new balance 600, and now we can withdraw 900 because we have an overdraft limit of 500. And you can see the remaining balance is actually negative 300. So we have to repay back the overdraft balance which we have actually used. So you can see this is our balances. So the key takeaways in here. So you can see we have the abstract classes here, and also we have the, you can see we have the interface, and also we have the abstract class. So the key difference here, we can have a state, for example, properties with values in an abstract class. So you can see we have created here constructor having a name in this particular abstract class. So this one is called a state or property with certain values, for example. But in interface, we cannot actually store this property directly. And a class can inherit only one abstract class. So a class cannot inherit another abstract class. So for example, inside here, let's create another abstract class. And we can say, let's say human being. So this one is called human being. Now, if we try to inherit more, so we can use a comma here, by inheriting human being, you can see that Kotlin is actually telling us only one class can appear in a supertype list. So this is a limitation which we have, but a class can actually implement multiple interfaces. So let's go here, for example, account operation. We can say, for example, interface. We can have bank account, for example, for bank accounts. But now the saving is actually a bank account. So we have account operation and a bank account, which can have different methods. So now when we add comma here, we can call a bank account and actually implement this method again here. Let's call bank account I. And here, let's add a bank account I. Okay, so have you seen that we have the bank account I, and here we have implemented having two, we have inherited from two interfaces. So this is a key difference in abstract classes and interfaces. So we can use an abstract class when classes are actually more closely related. So we can use to define an interface for common behaviors for unrelated classes, for example. So for example, we can have all kinds of bank accounts, and then we can use an abstract class for that. And for example, in interfaces, we can have any class that can actually transfer funds. So something like that. So in object-oriented programming, you can see we are creating our own classes and using them in our types. So we have type safety in all our places, but this one is going to limit us on reusability of code. So let's assume that we want to create a class that can be used by any data type without losing type safety. So how can we achieve this? So in object-oriented programming, we're going to use generics. So in this lesson, we're going to focus about generics in Kotlin. Okay, so now let's create here a new Kotlin class or file. Let's select file and call this generics. So you can think of generics as one design that can actually hold different types safely. Let's look here at a simple example. We want to create a bank vault. So this bank vault can actually hold, for example, documents, they can hold money, they can hold different valuable items. But we want to create only one class that we can actually inherit by different classes. So for this case, let's create here a class that is called bank vault. Now you have used generics before, but you didn't realize this. So the generics is using these two angle brackets. So by naming convection, you can use any type of letter, but by convection, we're using T to define as the type. So right now here, the compiler is going not to use T as a type. But whenever we pass in here a type, the compiler is going to substitute that with that particular type. So for here, we can create, for example, a private variable that is called item. But now we don't specify this item to be, for example, of type int. No, so we're going to use this as type T, which we have defined here. So you can see now it is highlighted in cyan color. Now we can open up here our brackets. We can create a generic function inside here. So for example, we can say fun get item. This function is going to return that particular item, but we don't know the type here. Could be a string, could be an integer. So we can use of type T. And here we can call our return item and call return item. And we can have another function. So you can see we used a generic type for return type. And here now we can call, for example, update item. So now here we're going to insert a new item. And this one is going to be of type T. So here we're using a generic type as a parameter. So we can call here the item and reinitialize with a new item. And we can write a println here. Now inside here, our main function, let's see how generics can actually work. Let's create a money vault. So we know the money vault is going to actually contain an integer or a double. So let's create here a bank vault. Now instead, we can just open up here, or we can specify the type by opening these two angle brackets. And here we're going to say, for example, type double. Now this type is going to be, so when you hover around, you can see that money, the bank vault is our type, but inside the angle bracket, this is going to be of type double. Now you can pass in here, for example, we have the vault $1,000. So we can call it manvault.update item, for example. And now we can have, for example, we have added 2,500 item. So T is now double inside here. Now again, our bank vault, we can create, for example, to store strings. So let's create here our document. Let's say this one is going to be a bank vault. We can use a type of inference for Kotlin. For example, let's say this is the land title. Now inside here, our document vault, we can update an item. So let's say this document was not a land item. So we can change this to a new item and call passport, for example. And again, we can try to actually use that item. So for example, let's call here a println function. We can call here our get item. Let's duplicate this. Instead of money vault, we can say document. Now let's execute this. So you can see here we have the vault that is updated with the new item. And here is we printed the item that we contains 2,500 and our document vault contains a passport. So what's happening here? So T means it's going to be a type parameter. And T can represent any type. So an integer, string, double, or even our own classes, which we actually create. So the compiler ensures type safety. you can accidentally store an int in a vault meant for strings. Okay, so in Kotlin, we can make a function to actually stand alone without a class. So also we can make a function generic. So let's assume here, for example, we want to create a function that can print something. So we can create this by using a type T. So let's create angle brackets and pass in the type T to be the function. Then we can provide the name. So for example, print item. Now this function is actually generic, and we can call the item that is going to be of type T. Now let's create here a println, and we can say item is of type item. So this function is generic, can be used by any type. So for example, let's come here below. We can call, print item, and the item is going to be of type T. So we can say 100. We can even call here a string. So let's say, so this one function is going to actually work for any type, no duplication, and still we have type safety. Okay, sometimes we want to actually have type constraints. So type constraint is going to allow you only certain types like numbers or accounts. So we can use an a type conversion to actually limit something. So for example, let's create here a function. Let's go above here and create a function that is going to actually constrain this. So we can create type T. So now type can be anything here, can be an integer, can be a double or anything. But we want only this type to actually be the account operation. So when you come here to interface, we have this as account operation. So now let's call account operations from our interface class here. Now we can say show account details. So here we can have our account is going to be of type T. Let's call here our account to show balances. So here is we have created a function that is called show account details, and we have restricted the account operations. And right now we have access to the methods. So if we remove, for example, this account operation, you can see now we don't have access to this show balance method because type T can be anything that is unknown even to our imagination. So for this case, whenever we add the account operations, now the show balance method is actually available to us. So not only is going to have us access to other methods that are available to that particular class, but also now we cannot actually assign this to any type of variable. So let's use here an S, for example, for an account. So we can call here our saving account and give it, for example, let's give it 100. Let's duplicate this and use C for current account. Let's call here our current account. Now it's going to be 200. Now we can use the function show account details. So inside here, we have to pass in a type T that can be generic. But now we cannot just pass, for example, 100. We're going to get an error here. So you can see argument type mismatch. But when we pass in here S, then the error goes away. And this function can also work with, for example, current account is going to be C. But these are different types. So this is how you actually use type constraints in Kotlin. Why generic matters? So it actually helps us to reuse code across many data types. And we can catch type errors at compile time rather than at run times. So we can make our APIs cleaner and more flexible to adapt to different data types. We have seen how we can create classes, how we can use the classes in inheritance and different aspects of object-oriented programming. But in Kotlin, there is one class which is called an object. So for example, let's say we want to create a class that can be a util class like bank utils that does everything, for example, generate account number, print bank name, some utility functions. So we can group this in one utility. So in Kotlin, an object is actually used. So let's create here So new Kotlin class of file. Let's select Kotlin. Let's select file. And let's call these objects. And here we can create, by using the object keyword, we can create, for example, bank utils. Okay, so by creating here, by using an object, our bank util is actually a singleton. So a singleton means a class that is going to have only one instance. So throughout our application lifetime, this class is going to be only one. So we cannot create multiple classes of bank utils. So inside here, our bank utils, we can create functions like, for example, let's call this generate, that is going to be of type string, and the ID to be of type int, for example. And this one is going to return string. So a simple function like that. So here we can return, let's call here our prefix. Then we can use our ID, convert this to string and call add to start. So we can add here an item. So at start, we can call the length to be 4 and add 0 here as our character. So we have to use single quotation here because we're going to pass in the characters like this way. So we can create here a simple a simple bank account number. So for this case, we can go on different places. Like let's go here to our generics. And here we can create a generate account. So we can use and say, hey, generate account number for first account. So we can just call here our bank, our bank utils dot generate account number. So we can give it a prefix, for example, account, the ID to be, for example, 5. Now we can print, let's call here print and call account number 1. So we can use this class in different places, and we did not instantiate this class if you look closely. So let's run here. And here you can see we have this account number. Okay, so this way we can create a static class. So a class, as how we did here by using an object. So let's say we want to create a static function. So we can use a companion object. So a companion object is going to define static like behavior inside a class. So maybe wondering what is static behavior. So static behavior refers to actions and data that are associated within a class itself, rather than within a specific instance or object of that particular class. So let's say here we have inside our class, we want to create here a static function that even without initializing this bank vault, we can actually use that function. So let's go to, for example, let's say, for example, inside here, bank vault, we want to actually create a companion object. Let's create here a companion object like this. And here we can create a variable. So for example, a private variable that is called total accounts. Let's say, for example, this one is going to be 0. And we can create functions to actually increment or decrement. So we can create register bank account. And here it's going to be of type int. Now you can call here, for example, total account and increment this variable, and you can just return the total accounts. So as simple as this, we can actually show the account, and here you can create another function that is going to show, for example, total accounts. So now let's say we want to actually register an account inside this bank vault. So let's go to even a main function. Now, let's say we call here our bank vault. Now, we did not initialize this, but we have access to the register bank account. So in this way, we can actually register a certain bank account by using this register. So right now here, it's going to actually execute this function inside here. So this is how we create static functions inside Kotlin. Okay, so why does this help? So it's actually important and helps manage shared data and functions. And also it's going to reduce code duplication and actually mimics Java's static feature. So if you're coming from Java, then you know static functions. And actually it's useful for actually keeping constant singletons and instance tracking. Let's create here a new Kotlin class or file. Let's select a file. Let's call this Enums. So an enum is short for enumeration and actually is used when you have a fixed set of constant value. So you can think of it as a predefined list of options. So for example, we can have account types in a bank. So we can have savings, we can have current or fixed deposit. So this way we know our list. So we can create here an enum class. By using this enum class keyword, now we can create an account type. So here we can create a variable that each account type is going to have that constant. So for example, each account can have the rate for monthly fees. So rent for monthly fees, let's say rate. So inside here, we can create a savings. Now let's say the rate is 3.5. That is the monthly fee. Now we can add a comma here. We can say we have a current account. And this one is going to be 0.0, for example. Has no monthly fees or fixed deposit. Let's say it has 1.5. So now you can try to actually use this type. So let's create here a main function, for example. You can create here, for example, let's create a class. Let's call this bank account for EN for enumeration. And here you can create, for example, the account type. And you can use this as a type here. So for example, we can call our account type. So now when we construct a bank account inside here, let's say we call here bank account enumeration, and we are supposed to pass in here the bank account. So the account type. So we can call here account type that is enumeration and call dot. For example, this is the fixed deposit. So for this way, we can actually use this constant and no need to actually scatter the variables or remember this. So for example, whenever we want to loop and actually check if this account type is going to be this way. So let's say, for example, we can use here an if statement, and this one is going to be easier for us. So we can assume if the bank account is going to be equal to, we can use the account type dot. For example, if it's a saving account, let's call dot account type. Okay, so we are using this type directly here. So we can check if this is saving. Actually, we can try to actually print item and let's say, and you can try to use options which are available. So for example, we can say bank account list. So let's call here bank account and convert this to, sorry, not bank account list, sorry, account type, and call dot. You can see we have values. So values is going to create an arrays, but this one is actually going to be pretty perfect. So we have entries. So right now, when you select this, this is actually enum entries of account type. So now we can use here a for loop. So let's call here bank account, for example, bank account list. And here you can see actually when we call for each, we can actually call the for each function here and actually Println, and we can call it. Now you can see we are going to print all of this. Let's try to run here a generic. Sorry, let's run this. Okay, so inside here, you can see we have printed all of this. So sometimes this is useful as you can try to use them. Whenever we start Android development, you are going to see enum entries used more often. Okay, so we have seen enums whenever we want to store constants and actually try to use them inside our program. But Kotlin provide another type of class that is used to keep constant, but actually it's an advanced version of enum class. This is called a sealed class. Let's create here another Kotlin class of file. Let's select Kotlin and file. Let's call this. So we have said SLD class is like an advanced version of Enum class, but instead of just specifying constants, each subclass can actually hold different data or represent different states. Let's assume we have a state that every transaction in our bank can have three possible states. A success, the transaction worked fine; a failure, so something went wrong; and a pending, so for example, still processing. So here we can define a SLD class. It's going to hold also constants, but now we can try to use it more by using objects. So the SLD class ensures that all subclasses must be declared in the same file. So here we can say, for example, transaction, and this you're going to see more often whenever you use Android development. Now we can specify a data class. Now we can use success. So we have our first data that is going to be a new balance. Let's say, for example, of type double. Let's call this our transaction result. It's going to inherit from this. Now, again, we can define another data class. Let's press Command D. And instead of success, let's say this is the failure state. And here, instead of passing, we can say error, an error message. And this one is going to be of type string. But this also is a transaction result. Now, we can have a pending result that doesn't need to be a class. So here we can use a data object. So a data object does not hold anything. So this one is just a pending. So we can say pending, and this one inherit from the transaction result. Now, for example, we can have a function. Let's go to our main function. And here, let's create a class, a normal class, for example. Let's call this bank account, and we can call this SE for sealed to have a balance like that. So we can have a very simple function that is called withdraw, and here we can call the amount to be of type double. Now, this withdraw is going to return a transaction result instead. So transaction result here. So we can say, for example, let's use a return here, and we can use a when statement. Now, inside here, we can say, for example, if amount is less than or equal to, for example, 0, then here we can call our transaction result dot failure. So here we have to fail this because here we know that our amount is less than 0. Now, let's say if our amount is actually also greater than the balance, we can return again the failure. So we can call here transaction result dot failure. And here we can say insufficient balance. And else, if it's not the case, then okay, so we can say balance amount minus the amount. And here we have to call our transaction result dot success. And here we can return a balance amount. So here we have three conditions that if our amount is less than or equal to 0, then we can say, hey, this is an invalid amount. You cannot withdraw 0. And if the amount is greater than the balance, then this is insufficient balance. And if not, then we can perform here. So we can decrement and actually return a success and say, hey, we have a new balance here. Now, inside here, our main function, let's create, for example, an account. And here we can call our bank account SE for our SLD class. Let's say we have $500 as our balance. Now we can define here a when statement. And inside here, we can actually define a variable. So let's say this is the result. So this is the Kotlin syntax. So we can say account dot withdraw. Now we're going to withdraw $600, for example. Inside here, our result. So when you see this variable here, you can see it's going to return a transaction result. So inside here, we can call our transaction result dot, for example, success. And here we can write a println function. And we can say balance and call our new balance result dot new balance because we have scoped this to a success. Now let's print this again. Let's duplicate. Instead of success, now we can call result dot failure. Now inside here, you can see we cannot access the new balance, but we have this access because we do not have the scope of success. And when you press Command B, you can see inside the success, we have this new balance. But for failure, we have the error message. So let's come here and see our failure. So we can say not successfully. So we can say failed with error. And here we can pass in the error message as simple as that. We can use another one, which is, so we can call here our transaction result dot ending, for example, we can use here. Now we can say transaction is ending. Let's run this Kotlin class. So you can see our balance is 500 and we have withdrawn 600. Now we get the error message, insufficient balance because of this. So as simple as this, we have used a seld class to actually perform a state inside our transaction. Hello and welcome to this section. So in this section, we're going to focus on functional programming in Kotlin. So Kotlin is a multi-paradigm language, meaning that it actually combines object-oriented programming with functional programming. So you might be wondering what is functional programming, then this section is going to actually enlighten you on that. So to understand functional programming, let's start with the imperative perspective. So far, most of the code which we have written has been imperative. We've been given the computer a step-by-step list of instructions like a recipe. Hey, add a salt, add this, add this, add this, then we can get this. So let's look at an example here to understand the imperative style. So I want to get the names of all active users. So what will you do in this situation? So at first, you create, for example, an empty list called active usernames. Then you can start a loop to get through all the users in the main user list, for example. Then inside the loop, use an if statement to check if the user is actually active. Then if it is, add that username to the active usernames list. Then when the loop is finished, give me the active username list so that we can start. So this works, but we are focusing on the hows. So, hey, I want this. So let's go step by step until we reach to get the active username list. So there is no problem with this way of thinking, but we are thinking on the hows. So let's look at functional programming. So functional programming is actually declarative, meaning that you describe what you want, not how you want to get it. So for example, let's go with our example. I want to get the names of all active users. So how will we do in this? So give me the user list, and then we can use that list to filter to only the active ones, then map through that so that we can get the result of their names only. So this is simply one line of code so that we can actually get all of this. So we are describing what we want and not how to actually get it. So this is the fundamental shift from managing step-by-step mechanics to describing the desired outcome. Let's look at the core pillars of functional programming. The first one is functions are first-class citizens. So what does this mean? Is that functions are not special. They are just another type of value like an int or a string. So meaning this, that we can assign a variable to a function. So we can store a function in a variable. So for example, we can say val a equals to a certain function. Then we can pass function as an argument. So inside that function, we can create a function and pass it as an argument to another function. Then we can return a function from another function like a return type, as how we did with the strings, int, or any type of data. Then another case, immutability of data. So the data shouldn't change in functional programming. So you avoid changing the data once it's created. Instead of modifying an existing list, you create a new list with the changes. Another case, we should have pure functions and avoid side effects. So what's the pure function and what's side effects? So, for example, a pure function is that whenever we give the same input, we'll always return the same output. So if we take a plus b inside the function, by using any type of input, that should return the same result. So meaning that this is the pure function, and we should avoid side effects. So it doesn't changes any state outside of itself. So for example, if we have a variable that is outside the scope of that function, then it's going to iterate that variable. So that we are calling side effect because it's changing something outside of its scope. So in functional programming, we should avoid functions that actually has side effects, and we should write pure functions. Now let's focus on functional programming. So inside here, let's inside the advanced, let's create a new class of file. So you can press Command N or Control N, create a new package. So inside here, we're going inside the advanced, and we want to call this functional. Okay, so inside here, we're going to create a new class of file. Let's select file. Let's call this basics. So in Kotlin, we have a concept in functional programming that is called a lambda. So a lambda is a function without a name, also called an anonymous function. So it lets you create reusable piece of logic directly where you need it without formally declaring a named function. So it has a different syntax. So let's create here a simple example. Let's call this greet. Now this function takes a parameter that is called a name of type string, and this one is going to return a string. Now here you can say, for example, return. So this is a normal function everybody knows in Kotlin. But when we want to declare a lambda function, we're going to use a different syntax. So we said that Kotlin actually treats functions as first class citizens. So meaning that we can assign them to variables. So for example, we can create a variable, and this one is going to be lambda. So understanding lambda is going to be a core of understanding functional programming in Kotlin. So for example, let's declare here, this one is going to be the lambda name, which we are going to actually declare the variable name that is normal. Now it's going to have a different syntax. Then here we have to provide the data type for this. So for example, here is going to be the input type. And using this arrow bracket is going to define the output type. Then we can assign this by using these two curly braces. We're saying, hey, we want to actually assign a functional uh, parameter. Then here is going to be the parameter name, and opening this, then we have the functional body. So this is the syntax of actually declaring an anonymous function or a lambda function. So it can be confusing for now if you're not actually used to this, but it's really simple. Okay, so let's add a comment. So this is the way of declaring a function. So let's declare this function in this syntax format. So here we're going to declare a variable. Let's call this greet. So we can declare here the type. So the type is going to be of type string. By using these brackets, then we're defining this is going to be the type. Then opening up this arrow, then we're going to define the return type. So the return type or output type, that is going to be the same. Then we can assign this to a variable assignment. Then now we can define that parameter to be what is it. So for our case, this we want to be name. So this function means that we are taking an input as a string, and the return type is going to be a string. So let's call this return type, make it more explicit. So here we have the input type and the return type. So this is the return type. So here we are supposed to return. As you can see, this function gives us an error. So return type mismatch. So we have to return something. So now we can say hello. Let's use our parameter name here, and we can call hello. Sorry, we can use a string template name. So this function is essentially the same to this, but now we have used this simple syntax here. And for example, let's create here a main function. Let's use this particular function. Let's say Println. Then we can call the greet with, don't use this one. This one is as a variable, so you can see Kotlin differentiate this with a v and f. So this one is going to be a variable, but it's actually a function. So to execute this, we have to use, we can call here dot invoke, for example, to actually invoke this. And you can see we have to pass one parameter that is called of type string. So here we can say, for example, Aisha. Now let's try to execute this. You can see the code, hello, Aisha. So as simple as this is how you can introduce Kotlin Lambda functions. Now we can even simplify our syntax here. So this one here is generically we have used a strong type. So Kotlin can actually infer this type. So let's duplicate this, for example. Let's press Command D or Control D to actually duplicate this. Let's call this greeting1. Now, Kotlin is actually strong, so it can infer even the data type of this. Let's just remove this one here. So now here we can just say, hey, this name is going to be of type string. So right now, our Kotlin is going to actually infer the data type. So you can see when you hover around here, you can see greeting1 actually takes in a string and returns in a string. So it's actually similar to what we have written here, but Kotlin has actually inferred the type. Instead here, we have defined the name to be of type string. Now we leave everything to Kotlin to infer this. And we can even simplify more because we said this is an anonymous function. So we can directly execute this piece of code. Let's just remove this and actually just copy this. And we can paste it here to execute this piece of code and open up this bracket and say, let's execute this code here. So you can see similarly here we are calling hello Aisha because we just called this second println here. So this is how it's called. So this is an anonymous function directly here by passing this piece of code, we actually execute this. Now let's say we have a function that actually requires to take uh, more than one parameters, for example. How can we actually achieve this? Let's assume we have a function that actually is going to take two numbers and add them. So for example, let's call this add numbers. We can take a of type int, for example, and b is going to be of type int also. And this function is going to return an int. So here we can just call return a plus b. So this is the normal function which we have to do. So how can we translate this to a Lambda function? So we're going to use the similar syntax like this, but with a slightly changed name. So let's create here another function, another variable that is going to actually use that syntax. So we can say add the numbers. Now we're going to let Kotlin to actually infer the data type. So we can take A of type int and B of type int. Then we can open up here our arrow bracket that can take A plus B. So if you have noticed, after this, this arrow here is where we can actually execute the code. So this one is the body of the Lambda function. So here you can execute any type of code, and here is where we are declaring the input type. So let's hover around here, and you can see Kotlin has inferred this. So it has used these brackets, int, comma, int, and then returns an int. So this is the data type of this particular here. So you can let Kotlin to actually infer this. So we can actually execute this piece of code, let's say println, and call add the numbers. And we can use a shorter syntax other than calling .invoke. So here we can actually just open up these brackets, and let's say we pass in 4,6. So this one is going to take 4 and add 6 to this. Let's try to execute. Now you see we have here 10 as our input. So this is how you actually use 2 or more parameters. So if you want to add another parameter here, you can just use a comma. For example, let's use C of type int. Then we can take A plus B plus C. So you'll see here, we have to pass in another parameter inside our add numbers. So for C, let's say we add 5. Now we have 3 parameters which we have passed here. So the data type, you can see it's int, comma int, comma int, that returns an int. So even if you re-execute again, see now we have 15 parameters. So you can just keep adding and adding parameters wherever you want. Okay, so far we have been using here types and parameter types and names directly in our code. So this is actually correct, but sometimes you might encounter this. Whenever your Lambda has only one parameter, Kotlin automatically provides the name for that particular parameter. So let's declare here a simple function or a variable that is called square. So here we can give it the type. Let's say this is going to be an int, and this return an int. So we know that a square, we can just pass in one variable name, for example, 5, and then return it. So in Kotlin, when we do not provide here the type name, for example, here we have provided the type name. Now we can access this A. So if we do not we omit that A because we have only one parameter, then we can actually use it. So we can call here it multiplied by it. So here it represents the argument that is going to be passed to the Lambda. So as here our function is actually taking an int as our parameter. So here it's going to take it multiplied by it. And when you hover around, you can see this is automatically declared based on the expected type. So our expected type is actually int. So even if this could be double, then similarly, this it is going to be actually double. So here we are taking double multiplied by int that will return actually an int. So that's why we are getting an error. So this one is going to be any data type that is going to be expected here. So for example, we can just call here another println function and execute the squares. Let's call here a square and pass in, for example, 5. Let's run this. Now you can see the squared is actually 25. So far we have been using lambdas as variables, and you can see here we can achieve this same thing with a normal function. So why should we actually use this weird syntax? Sometimes it's just confusing you. So you are absolutely correct for that case, but lambdas becomes really powerful when actually we pass it into another functions. So previously we said that we can pass in lambdas or functions as another parameter inside another function. So these functions are actually called higher order functions. So for example, let's create a higher order function that is called apply numbers. So we can create a normal function. Let's call this apply numbers. Now inside here, we can pass a number of type int. Now, instead of passing another parameter here, we're going to pass in a function. So a lambda function. So for example, we can just call here operation. So this operation could be different. We can actually reuse this apply to number with different types of operations. So our operation we know is that we're going to take a type of int and return type int. As simple as this, then this function is going to return an int. Okay, so here we're going to return. We're going to actually execute our operation. So let's call here operation. Then we can use a num. So this is actually a normal function to actually execute. So we are going to return an int. And here, this is a function that takes in a parameter of type int, and this is going to return of type int. And here we actually execute that. So in actually Android development, you are going to see a lot of anonymous functions like this are used, or higher order functions used in Java Compose mainly. So we can come here inside our main function and actually use this. So for example, now we can create a double. So we can just call apply numbers. Now we can pass in a number like 5. Now inside here, we have to pass in the Lambda function. So easily we can just open up these two curly braces to actually execute a Lambda functions. And now we know that we have only one parameter. So we can use it multiplied by 2. So this is a simple syntax. Let's create another function. Let's duplicate this. Now, instead of double, let's say triple. So we want a triple data. So we can take the variable to be 5. Now we can take it multiplied by 3. So we have not created a separate function to actually do this operation. So directly we have used a Lambda function. And here you can see Intelj is highlighting us. Lambda arguments should be moved out of parentheses. So this is another syntax. You can directly push in the Lambda function inside here, or you can move it. Let's select move the Lambda. So this one is a cleaner syntax. So here is the body of that Lambda function. This is called a trailing lambda syntax, meaning that if we have a lambda function as our last parameter, then that parameter can be moved outside of that function execution. So as how we did here. So you can see inside here, we actually executed this inside that function body. This is normal as how we do every day. But this is called a trailing lambda syntax, and you're going to see this more often whenever you program. So this happens if the lambda function is the last parameter of your function. Let's say if we flip this around, let's place option return and call flip. And you can see may change semantics. Right now, you can see we are getting here an error that argument type mismatch. So we should only just use this. So let's change here and flip again. So now you can see everything is working perfectly. Or if we pass in here a parameter to be, for example, a to be of type string. So you can see this one actually, again, it's not perfectly. So we must just leave this as the last operation to actually have a trailing lambda syntax. Okay, so to iterate more on higher order functions, let's assume that we have a shopping shop. So inside here, we want to calculate price of a customer, but this one is going to be different on, for example, the first customer or actually the recurring customer. So how can we actually do this? Let's create here a simple lambda function. Let's just go below here. Let's create a higher order function that is called calculate price. So here we're going to pass in the price as double. So now we can create a discount. So this discount is going to be determined if the user is actually an everyday customer or a one-time customer to give them a different discount. So this one is going to take in double and return double. And here our data type is going to be of type double. Now we can just return and call our discount and execute our price. Okay, so we have here our higher order function that actually calculate price. So similarly, we can just use this for our first customer. So here we can execute our calculate price. So let's say this user shopped for $500. So inside here, we can directly move this outside to use the trailing lambda syntax. And you can actually open up the curly braces like this. So we can take it multiplied by 0.1 to be 10% off. So similarly, we can just duplicate this. Okay, so it has kept this outside here. Let's just keep it inside here. So instead of 10%, we can say, for example, of price. So we can use it divided by 2. Now you can see after 10% off, we can actually use this. So let's execute. Let's create a Println function. And we can say after 10%. So we can use that 10% off function directly. So right now, let's open up here our string template. Let's call our calculate price. Let's call here our 10% off. And another case, for example, half the price. So we can just remove this redundant curly braces. Okay, so this is how we actually execute. Now let's run this. So you can see after 10% remove from this, you can see we are getting this, and here we are getting 250. So this is actually the 10% that the guy is going to receive, and this half the price, this is what the guy is going to receive as discount. We have seen a higher order function that takes in a parameter here as a function and actually just return a normal type here. So we said also function can be returned as functions. So we can create a function that actually returns another function. So for example, let's create here a function that is called, for example, make multiplier. Okay, so this function is going to take a factor, and this one is going to be, for example, of type int. Now, the return type here we can define similarly as how we used. So we can say, hey, we want the return type to be type int and return a type int. Okay, so here we have to return. So what should we return here? So you can see this type is going to actually expect a function of type int and int. So we can actually create here a lambda function and say, hey, we're going to receive a number as our functional parameter. So we can call that number multiplied by the factor. So this is the function. So we say, hey, we are going to receive a parameter of type number, and this parameter we're going to multiply by this particular factor here. So this is how we actually return. So let's go to our main function, for example. We can create a variable that we can say times 2. Let's call our make multiplier. Sorry, let's change this to small capital letter. Let's make multiplier. So here we are supposed to pass in a factor. So let's say of 2. Now let's look at the infer data type. So you can see the infer data type here is actually an int of type int. This is something which we have actually returned here. So this is what we are taking in an int and returning an int. So this is actually a function. Also, we can just duplicate this. So we can say times 3. So we can say here the factor is actually 3. So this is now a function. So when we try to println here and call times 2, for example, without executing anything, so let's just run this function here. So you can see we are directly just printing here is the reference to this particular function, because now this is not a normal variable, this is just a function. So we have to actually execute this. And when you call times 2, we can call dot invoke to actually pass in the parameter. So what is the number that we want to be multiplied by 2? So for example, let's use a 5. Let's duplicate this and call the times 3. So we can use a shorter syntax by just opening this bracket. Let's say, for example, we want also to be multiplied by 5. So now let's re-execute again and see the changes. So now instead of seeing the reference, we are directly executing the code. So we have 10 and we have 15. So this is higher order function that actually returns a function. So far we have created our own functions and higher order functions in Kotlin. So we have an enormous library of built-in libraries. So we have a huge library of built-in higher order functions that you're going to encounter in your day-to-day life. So let's create here another Kotlin class inside the functional. So let's create here another Kotlin class of file. Let's select file. And here let's call this built-in functions. Okay, so you remember loops. We actually used them to go through each element in a list and do something. But Kotlin gives us smarter tools, functions that handle this pattern for you. So you just tell Kotlin what you want and not how to actually do it. So let's assume, for example, we have a names list. Let's create here a list of, let's say, Asha. So we have 3 names here. Now we want to iterate through all the names and actually perform something. Let's create here a main function. We can easily create a for loop. So for example, we used for names. So we are describing what we want to do. And then we can create a println function and actually print a name. So this is imperative way of thinking. So Kotlin gives us a higher order function that we can actually achieve the same result by calling, for example, names.forEach. So do you remember this syntax here? So this is called a trailing lambda syntax because this is the only parameter which we have here. So when you hover around, you can see, or let's press Command B to actually go to the declaration site. So you can see they're using here generics on this function that is called iteratable and creating a for each. So inside here, a for each, you can see we have the action that takes in of type T and returns a unit. And then it's going to perform this element for us. So actually, this one is going to perform this action for us as a for loop inside here. So this is actually how we use a for each. And this one is going to actually perform a println function name. Here we have it not using names. By using names, we are using this function. So here directly, we can use it to reference this. Let's run this code. Now you can see it's actually iterating through all of these variables here. So let's assume we have another list that is called numbers. So we can declare a list of 1, 2. So we have a list of 5 numbers. Now let's say we want to actually have, for example, a squared number of all of these numbers. So for example, let's create here and call this squared. So by default, we could actually loop through this and actually perform an action in order to get that. But easily in Kotlin, we can achieve this by using the map. So when we call map here, we can actually use a transform. So when you hover around, you can see this one is going to take up a map and the transformation. So it's going to take T and return R. So here we have our variable that is going to be it. Or we can directly change here the number and say num like this to access our number. So right now we can take num multiplied by num. Now you can see we have created a new list that is actually a squared list of type int. Now let's try to make a println function and let's actually print this squared list directly. Now let's run this. Now you can see our list here is directly kept, and we can actually combine different types of operations inside here. So you can see right now we performed a map operation. Let's assume that we want to actually perform here a for each again. So we can use a dot operator and use a for each. So we can say this one is going to be squared right now. So we perform the iteration. Then after the iteration, we want to perform another iteration actually that is going to print that. So let's write here println function and say the squared number. Let's use the squared here. So here we're performing the first iteration to actually square this. Then this second iteration, we want to actually print this. Now let's execute again and you see the changes. Now you can see we have actually iterated this. So we had 1, 2, 3, 4, 5, and now we have 1, 4, 9, 16, and 25. So that is the squared number of our particular list here. Okay, so now we have here the squared numbers. Let's assume we want to filter and get the even numbers. So inside here, our list, we have the list of 5 items. So we want to only filter and have only the even numbers. So how can we do this? Let's create here a variable and let's say even numbers. So now we can call here our numbers and use a higher order function of called filter. So inside here, we have to pass in the function or a condition that should match. So for even numbers, we can use it and use the mod operator to actually divide this by 2 and say that the result is going to be 0. So this is called a mod operator. So if the number is going to be divided by 2, the remainder should be 0. So for example, 2 divided by 2 is actually equal to 0. The remainder, nothing is remaining. If we take 2 divided by 3, the remainder is going to be 1. So this one is going to be false. So this is the case. Now we can say, let's say println even numbers. Now let's execute here. Now you can see inside here our list of 1 to 5, the even numbers is 2 and 4, and this is what our program has output. So there are other two functions which are going to be really important. So for example, if we want to find something inside the list, so let's say here our list contains this. We want to find a certain guy who his name starts with A, for example. So how can we achieve this? So for example, let's get names with A. So inside here, we can call, for example, names, and we can use the find. So when we want to actually find, and here we have to pass in a predictive value. So for example, we can say it because this is going to be of type string, and we want to call this start with. For example, we can pass in here A. That is going to start with A. Let's say here. Now you can write a println function and use names with A. Okay, so we can check, for example, if something is going to actually exist. So for example, here we found something. So we can say exist. So we can call names dot any. So when you hover around here, you can see this one is going to return true if at least one element matching the given predicate. So for example, let's assume that we have A, J, and S. We can look if there is any variable that contains something. So we can call it. So here we have to pass in a condition. It dot contains, for example, what element? So we can say, for example, does this contain a value that is called B? And then we can write here println function. And here we can call our exist function. Let's execute here function. So you can see names with A is actually Aisha. And here names that contains B actually does not exist. So it's going to return false. So this is good for conditional checking and searching. So previously we said that we can chain something to do multiple tasks. So we can do a complex task instead of writing multiple loops here. So let's declare here a variable that is called, for example, grades. Let's say list of, for example, this is the list of the class. So we can actually combine all of this to have something. So let's declare here a variable and say past students. Now we can call here a grades variable. Now let's call filter. First, we want to filter only past students. So we can say it is greater than or equal to 50. So this student has passed. Then we want to map through all of this. And then we can just say, hey, we want to return. We can perform here a for each to actually print this. So you can see we have performed several actions. So we filter first, then we perform a map, and then we perform a for each. Then after that, you can see this one is going to be unit. So no need to actually provide a variable to call this students. So let's just use the grades because we are performing all actions here. Now, after this, we can just run here. Okay, so you can see these are the all grades that passed. It omitted the grades that did not pass. So you can see there is no 20 here because we had somebody with 20 grade. And now we actually change this by using grade it. Okay, so these are some of the higher order functions that you are going to encounter in your day-to-day life of programming with Kotlin. So check the library. There is pretty much more functions that you can try to use them. So these are just some of them. Okay, so in this lesson, we're going to speak about scope functions in Kotlin. So scope functions are Kotlin's most elegant features. They make your code cleaner, more readable, and expressive, especially when working with objects. So inside here, let's create a new Kotlin class or file. Call this scope functions and select file. So you might be wondering, what is a scope function? So a scope function lets you execute a block of code within the context of an object. So they're called the scope functions because they create a temporary scope for that object. So you can use them to do different things. So you can access or modify an object properties easily, avoid repeating the object's name, and chain multiple action neatly. So there are different scope functions which are called read, run, apply, also, and with. So let's explore each one with an example. So for example, you can have an object that is used as a string. So for example, let's create a variable. Let's just create a val. Let's call name. And this one is going to be of type string, but this is nullable. So let's say, for example, initialize this to said. So right now, the scope function is going to let you to actually execute this piece of code without using an if statement or using a, let's use here main function. Now inside here, we can call our name. And now we can use a scope function by using this question mark here and add the dot operator. Now we can call let. Sorry, let's call let. Now inside here, we can perform a println function. And for example, so right now you can see we do not get any null issues. But whenever we remove this, you can see we are getting null issues. So the let scope function here calls the specified function block with this value as its argument and returns its result. So for this case, then it's going to execute and return a result. So if you want to perform specific actions and actually return that particular result. And it's great for nullable types. It only runs if the name is actually not null. And also we can actually transform a variable. So for example, we can create here a variable. Let's call this length. Now we can use here the name. Now here we can call let. So inside here, we can call it dot length to get our length. Now, if this is going to be nullable, then we can just return 0. So let's change this var to var. And here name, let's make this to be null. Now you can actually see that this is Kotlin is actually essentially checking that if it's okay. So let is actually great working with nullable types. So as how we have seen, so you're going to see more often that you're going to use let for dealing with nullable types. Okay, so we have another scope function that is called apply. So here we have a let scope function. And all of these are actually higher order functions. You can see we are using here a trailing lambda syntax here. So we can use the apply when you want to initialize or configure an object. Let's say here we have a data class. Let's call this, for example, student S. That is a scope function. We have the name. Okay, so for example, here we initialize a student. We can construct here a student. Let's say we want to perform under initialization of actually providing the names. So here you can call dot apply. So here we're just using a generic example. So you can say, hey, why are you doing this? So here, for example, we have access to the properties. So we can check here, for example, name and make this to Asha, for example. We can say grade equals to, for example, 90. And here we can do even other operations. So we can say if name. So if we can say the name is, for example, is empty, then we can do something. Hey, maybe you can throw an exception or do anything. So this is a great place to use the apply scope function. So apply is going to return the object itself. So it's perfect for setting up the objects. So you can have some things to set up. You can have the condition to check. So the next case is we have the run scope function. So with the run is similar to let, but it uses this instead of it. So it's best when you want to perform operations and actually return a result. So for example, we can create here a variable. Let's call this message. Now we can call this Kotlin. So this is directly here a function. Now we can create here by using the run keyword. So you can see, and when you hover around, you can see what's called, calls the specified function block with this value as its receiver and returns its result. So it's best when we want to perform an operation and actually return the result. So for example, we can return here the result. word. So here we can actually use this to actually obtain that result. And here call the length. And we can perform even a println and pass in here the message. So you have seen we have used this scope function inside the Kotlin to actually execute this. Now, when you try to run this function, for example, let's try to just run this. So you can see the word Kotlin has length 4. So it has 4 items here. So that is how we actually use this. So you can think of run as do something and give me a result. And also we have another keyword that is called also scope function. So you can use also for side effect when you want to do something extra like logging but still keeping the same object. So for example, we can have a variable. Let's call this numbers. So we have 3 numbers. So we can call here numbers dot also. Now we can do a println function, for example. So here we can use it to actually access that variable. Then we can perform another function and call here add. So let's add 4 or 3 numbers. So you can see we're still having here the list because here also is going to return that particular item directly here. So calls the specified function with this value as its argument and returns this value. So for this case, we have performed here functions by println. And then again, we still have access to the mutable list. So we can add here values. Now we can call here println after adding. So you can see numbers here. Let's re-execute this. So you can see before adding, we have this. And after adding, we have this particular action here. So you can see here also is actually perfect for bugging and also chaining some actions so that we can perform other actions as here you have seen printed before. So you can see here we can debug then after, but we have actually added another item after we perform a certain operation. So again, we have another function that is called with. So with is slightly different. It's not an extension function, so you can just call it like this. So for example, let's call this a student. Let's say this student is Juma and grade is 85, for example. Now we can call with student 1, for example. And inside here, we can directly just use a println function. Let's say, for example, student, and use the name without calling, let's just call here the name. So you can see we're using the receiver student type name directly inside here. And for example, we can call here grades, and here we can just call grade. So you can see we are directly using this without calling student dot. So you can use with, which is going to give you actually the context of this receiver. So calls the specified function block with the given receiver as its receiver and returns its results. So it's just a neat way to actually access multiple properties of the same object without calling dot dot dot. Can you choose the right scope function for your job? So for example, you can transform or use safely, especially with nullable, by using let scope function. And apply, you can use to configure or initialize objects with some variables. And then run is going to run a block and return that result. So if you want to run that block of code and get the result. So also you want to do extra action like logging, and with you want to work with an existing object, but you don't want to actually destructure it and get all of those dot dot dot. So for example, you can have an object containing maybe 50 properties. So you want to access those objects properties without calling student dot name, student dot what until 50 objects. So for example here, let's create a simple analogy so that you can have a practical understanding of this. Let's create a data class. Let's call here bank account. Let's call this owner. That is going to be of type string, and the balance be of type double, for example. Let's call this bank account S for scope function. Now, inside here, our main function, we can call account, for example. Now we can initialize our bank account. So we can say the name is Asha. Here we can say, for example, the balance has incremented, somebody has deposited. So we can call here balance. You can see we have applied. So we can use also change this. So we can say Println. We can access the variable it dot owner. For example, if we want to use a summary, so we can create a variable and call this summary. So we can access this with account. With the balance. So here we can Println the summary. Now let's execute this. So here you can see we have the account updated for Asha. Now we have 700. So before we opened this with 500, now we update this with 200. So a quick recap here, we said let, you can use that object safely and return a Lambda result. Where, for example, if you have nullable values, apply you use to configure objects and return the object, and run you have to do operation and actually return the result. Also, you can do extra stuff, return the object, and with you want to work with that an object and return the Lambda result. Okay, so one of the excellent features in Kotlin is called extension function. So I want to cover this quickly so that you can understand extension functions in Kotlin. So inside here, let's create a new Kotlin class of file. Let's call this extension function and select file. Okay, so what are extension functions? So an extension function lets you add new functionality to an existing class without modifying its source code. It's like saying, I wish this class had this extra function, and Kotlin replies, sure, just extend it. So instead of using inheritance, we directly create an extension function. So its basic syntax, you can use a function and clause class name. And this is the new function name. And here you can use the return type and open up the curly braces. And this is the function body. So this is actually the syntax which you're going to actually often see. And this is widely used in Kotlin. So instead of using inheritance directly, you can just actually extend this. So let's look here at a simple example. So for example, we can have a function. Let's call this string. So right now here we're calling a string, which is a data class that is available inside Kotlin. So we cannot extend this class for now. So we want just to add a function that adds exclamation mark to a certain word. So for this case, we can call add exclamation. And this is going to return string. So this is an extension function that actually adds some extra functionality within a string class. So for this case, we can just return here. We can call this to actually get that scope, that string which is passed. Then we can concatenate this with the exclamation mark. As simple as this. So here Intelj wants us to convert this to concatenation like this. Okay, so now let's create here our main function. Let's call this message. Hello, Kotlin. Now we can call here Println, so it's normal, the message, and call add exclamation mark. So you can see this function now is available within a string. So now we used here a certain string, but we added this function hello exclamation mark. Let's just call this. Now you can see we have hello Kotlin with the exclamation mark, which didn't have here. So what's happening here? So string is a built-in class, but we just added a new function that is called exclamation mark. So inside the function, this refers to the current string object that we have that is called hello Kotlin in this case. So why use extension function? So they keep the code actually clean and readable and add custom behaviors to libraries and classes and avoid utilities, helper functions, or helper classes full of static function. So let's look here at another example. Let's say we have a list and we want to get the average grades. So we can just create a function that adds to a list of type int. For example, we can create here of type int. We know that we want to get average grades. So instead of creating a utility function, we are just adding this directly to our function. So it's more readable. And here you can see we can return actually, so we can do checks is empty. So we can check here is empty. We can just return 0, 0 if our list. Else, we can directly use the sum function, which is available inside the list. So you can call sum dot to double, for example. Then we want to actually divide this with the size. So here we want to get the average of the grades that we have. So for example, we can define here a variable called the grades. So what's going to be the average? Let's Println here. The average grade is, so we can call here our grades. So this is the list directly, but now we have the average grades function that we have. Now let's execute here. Now you can see we have here the average grade is 90. So with this case, we did not inherit anything from the list, but we added this function by using extension function. So extension functions versus inheritance. So inheritance actually modifies or extends the class through subclassing, as how we did before. But extension adds just functionality without touching the class structure. So you can think of extension as non-invasive enhancement. So we don't actually create a different type or we inherit a different subtype so that we can use it. Directly, we can use the same type. So you have to note that extension function don't actually change the class itself. They resolved statically at compile time. That means if you call an extension function on a subclass, Kotlin won't use polymorphism to resolve it. So congratulations, guys. So you've made amazing progress from learning about variables and control flows to mastering object-oriented functions, generics, and how functional programming actually works with extensions and higher order functions. That's a huge leap forward. You now understand how to structure your code with classes and objects, how to make it smarter using inheritance, polymorphism, and abstraction, and how to write clean, expressive, and modern Kotlin code using lambdas, higher order functions, and extension functions. This is exactly how professional Kotlin developer thinks and writes the code. So you can keep going, and next steps you could include exploring coroutines and asynchronous programming, and build a small project like a console app, and practice by rewriting your earlier example with cleaner Kotlin features. So every great developer was once a beginner who didn't quit. You've just proven you are on that path. Keep going.